Okay, that seems to be live. Welcome back to the stream, everyone. So, last time on Tuesday, we finished, well, finished is maybe a strong word. We made a lot of progress on the end of the analysis phase. We finished name checking, type checking for non generic functions. We are now very close to finishing the analysis phase. What I want to do this evening is to do one last bit of the analysis that is still missing, and that is the instantiation of generic functions. The way I approach generic functions is very similar to the way I approach, the way C++ approaches them, which is there is no trait in this language. So whenever we encounter a non-generic, an actual known variant of a generic function, we must instantiate it and include it in the object of a given module. I've been giving some thought on how to implement this, and one thing I was thinking about is I have already done some partial analysis of the generic function. I do name checking, I do type checking where I can, but anything that involves generic types, I just don't do. And I was thinking, well, I have already a resolved version of this function, an analyzed version of this function. Maybe what I can do is reanalyze it a second time when I know what the parameters are. But that would involve rewriting a lot of the analysis code. Another option would be to try to split name checking and type checking and do only name checking on generic functions and then do type checking when I actually know the types, when they are being instantiated. But this would break a lot of things, and not everything can be done that way, because if I don't know the types, some name checking can't be done. So, I think the solution I'm arriving at is that the simplest solution is simply to reanalyze, rerun the analysis of a function when we need to instantiate it with the correct arguments. This will be slightly annoying because it means we're gonna redo the name analysis and everything, but it should be fine. And there's gonna be a tiny bit of work in managing the context. So that's what I want to do this evening. And I will do probably one extra stream tomorrow evening before going on vacation to try to start writing some tests, since we are arriving at a point where all of those different phases we've been working on for a while are getting close to being finished. So, let's get started. Oop, there we go. And while thinking about this, I have not written any code outside of the stream, but while thinking about this, I've realized I think I have a bug in the current implementation that just hasn't been relevant yet. And that bug is simply, actually, it's probably actually working by sheer luck. The problem I have realized is this. If I go to, well, there we go, perfect, analyze definition, I have here something that says reset state. As in, okay, we initialize some state that is used for the purpose of the analysis of one specific declaration, and it needs to be reset in between declarations. That's fine. There is a problem, though, which is that a lot of the things we've done with context, specifically, where was this? The analyzable class thing, is sometimes analyzing a thing requires analyzing another one, which means we are resetting the state in the middle of a recursive call. In practice, I think it's fine, because the only case where we do end up doing analysis like this is for type aliases that do not carry any extra scope. Nonetheless, even if it works, technically, I think it's wrong. So we're gonna fix this, and fixing this means having a way of thinking, okay, I need to have a new state for the purpose of analyzing this thing. And that's going to be very useful when we need to run analysis of a generic function from another module at a later stage when it gets instantiated. Now, something I've been thinking about is maybe a mistake I'm making is I am using this state, the context here, for two different purposes. It is used both for the things that are like for the output of the analysis phase, for things that are carried through the analysis, but it's also used for things that are specific to one analysis, so the analysis of one declaration. And maybe that should not be the case. Maybe I should rethink this. And maybe instead, each definition runs its own state rather than like modifying, resetting the state like I've been doing, which avoids all of those issues. Another solution would be to introduce some kind of bracketing, and rather than having reset state the way it is, which is like erases all the function, like all the declaration things, actually takes a callback, sets them, calls the callback, and then resets them to what they were before so that we can handle recursive things. I am slightly leaning towards that second option because because we have recursive definitions, I don't want to be stacking state monads on top of state monads on top of state monads if we end up having definitions that depend on definitions that depend on definitions. Because that is a one way street to performance hell. So I think what we need to do is change reset state to instead being how do we name this? With local state? Yeah, with local state doesn't seem that bad to me. And what it does is it takes some action in the monad and returns a new action of the same type, but that is wrapped within a block that does all of this stuff. That probably also means that we need to catch errors, because otherwise, if we don't catch errors there, we have no guarantee that the code there will not, that the wind down code will be executed. So we probably need to use error handling there. So that would be action here. So what we're going to want to do is we're going to want to preserve previous scope, which will be obtained through a use of the context scope. And actually, all of those is what we want to preserve. Use previous fun type, well, use context fun type, and so on. So that way we get the previous state, we set the local state to what is needed for the analysis, we perform the action, and then we can reset the scope to what it was. Oops. It's not very elegant, but At least as long as we use this function instead of the reset one, we should never trash the state recursively with the reset that we're doing. The only thing I might want to change, and I think I'm going to change that here, is this takes the top level scope from the info here, which is dependent on the module. However, when we do the analysis of a generic function from another module, because we are instantiating it, then we need to reset the top level scope. Since we are going to redo the name analysis because we're redoing the entire analysis, we are going to need to reset the top level scope to the one of that module, which is extremely annoying and is the big downside of this approach. But that means here I should be taking the top level scope as an argument rather than doing this. And here I can just return the result. Okay. Now, what does this change for our analysis? So here, there's a few things that need to change. Because here, what happens is we had this reset state, which no longer exists. We need to change it. That's not too difficult. However, the big difference is this will return a maybe value now, which it did not before. And we're going to have to figure out, which means we're going to have to move the maybe here and figure out what that means overall. The maybe here meaning we encountered some kind of error, basically. Well, we may have encountered some kind of error. So let's do that. So here we're going to need to extract, we're going to need to get what we have changed, which was to get the top level scope from, so was this, let me have a quick look. It was with a view, of course. So top level scope. Come on. And here this has become a with local state that takes the top level scope, and the action we perform with the local state is this. Now, there's another thing that we might want to change. We might want to change here. We always add the new value, the computed thing into the cache, which, do we want to do that for generic functions? Because the version of the analysis of a generic function is kind of useless in the context cache. I think it's easier to just, at the end, when we're done with the analysis and we build the result, then do the filtering at that point and leave this code as it is. Okay. Okay. And here, this has to become pure just. since we are now going to be returning a maybe value, since we have the try in with local state to guarantee that even if we encounter an error, it is caught at this level. Okay. Which guarantees as well that if we encounter an error in a definition, we are still going to try to analyze the rest of the definitions. But there's something. I'm going to make this mistake that I often do of stacking more projects on top of the thing I'm already doing. There is a thing I would like to avoid, I think, which is that I would like to avoid, I would like to be able to, yeah, always, isn't it? I would like to avoid a problem, which is at the moment, since we have this try thing, we are gonna be able to always like catch, like we're gonna be able to like, in case of error, skip the current definition, move to the next one. However, that means that if we have definitions that trigger a recursive definition, that we have some A that contains an error, so we skip it, and we go to some B, but B depends on A not being in the cache means that we will try to analyze A because B depends on it, and we will get the errors from A second time. So we probably want the cache to itself contain a maybe, because we want to cache the fact that we have already done the analysis of that thing, even if it ended in error, to avoid having duplicate errors. I think we want to change that, which means I remove this I've just added, and in the cache, so here, this is gonna give me, wait, I'm doing this at this level. So the context cache will be, this is a part that is short-circuited if an error happens, because the try is within the with local state. So do I make the cache contain maybes or not? That might actually not be great. Let me think for a second. There is another option. I am using something that is this is not great, which is the info stack, which is this thing here, which is basically the stack of recursive calls to a definition of a analysis of a definition. Like, okay, to finish the analysis of A, we have to go analyze B because A depends on B in a way that we cannot resolve without actually doing the full analysis of B. What this does is basically keep a stack of all the things we're trying to analyze. If we ever have a cycle, A depends on B, then depends on C, that depends on A, then we detect it and we can abort the whole thing because, no, those things are mutually recursive. What I could do instead, since we do the check in the cache first, I could instead have. But if I was going to say, if I make this set of things we have already analyzed, then I lose the ability to. Detect cycles in this way. So no, I think I want to keep the cycle detection the way it is. I think that's the right approach. But maybe that means I need, beyond the cache, I might need to maintain a simple set of things we have already analyzed that therefore can be skipped safely. Is that the same thing as the cache, though? Well, no, because some things we have analyzed might not have a value in the cache, if we've tried and we encountered an error. Okay, where do we use a context cache? If we only use it for extracting the result, then it doesn't matter. If we use it for lookups within the resolution of things, which I think we do, we can't put a maybe in it. In contexts, we do look up names in the context cache. That being said, we don't do that a lot. So that's the lookup in, that's the check whether the thing is in the cache, that is updating the cache. We seem to only have one use in context. Could we put a maybe there? Uses context cache here, right there. Yeah, actually, this is probably fine. What this does is this tries to call the given callback, which can take something that is either already resolved or not yet, and try to call it on a foreign definition, a cache definition, or local definition. But there is still the problem of we then must resolve the thing. We must resolve B to be able to resolve to analyze A. We have tried B in the past, therefore we can't. We are gonna need at some point to do this detection of, oh, we're depending on something that failed, therefore we have to bail out. Would it be here? It would be here, I think. Basically, we do a lookup in the cache. Oh, we've already tried to analyze that thing that we depend on. Whoops, it is broken. Therefore, whatever we're doing right now would be broken, probably. That being said, it might not. For instance, I have a struct B that depends on the struct A. It is fine for it to depend on a struct that actually doesn't compile because it names something. As long as the names, it might still be able to compile. This is tricky. Maybe it's easier to say, okay, if you have something that depends on something else that is broken, maybe we just just bail out, basically. I do believe I have. I could just abort, yeah. Okay, so let's do that. I think that's the best option we have. So we are going to change the cache to contain a maybe of the resolve definition, which will be therefore a cache of we've tried to analyze this thing and we may have succeeded or not. This is going to change a few things. This is going to change this. And what I'm going to just do here is on nothing abort, which means we give up on trying to analyze the current. We give up on trying to analyze the current thing we're trying to analyze. This will be caught by the next try, which is fine. Which is fine because if we abort, it means, wait, let me check something. With my kind of weird implementation of this. Wait, no. If we abort, it means something has failed to compile, which means we have encountered at least one error, so we have the guarantee that yes, compilation will fail. Okay, no, this is fine. Okay, so now with this, we can go back here. So the cache here returns a maybe, that's perfect. It returns a maybe here as well. And now I have here to get the resolved definition will be the result of this with local state. And with it, this is now a maybe, so we're modifying it with this with location thing. And now we're adding that to the cache regardless of whether it succeeded or not. And all of that is now, and that's after the with local state. Okay. That should fix several problems, and that should create a bunch of new ones. The big one being we've changed this, and now all of the top level things of how we gather results from analysis of a module will be broken. Which is fine, since that's what we were trying to change in the first place for this evening. So, analyze definition. Oh, actually, there's another place where this breaks. There's another place where this breaks, and that would be here. What I have here, I have this complicated thing where some of the lookup functions are able to deal with either a passed version or a resolved version of a declaration, because sometimes no, like we can get enough information out of the thing we're trying to get by just looking at the passed version. We don't need the fully resolved version. And that breaks a lot of cycles. That's what allows basically recursive functions, because a function calls itself, it hasn't finished being resolving itself, therefore it needs to only look at its past definition to check that everything is fine. And I'm using several layers of this to have basically take something that's analyzable, which might be passed or resolved, but I have a way to force resolution for places where we actually need the resolved version. And here, this calls analyze definition. And I guess we are gonna need to do we are going to need to do the same thing, basically. Oh, we try to get the definition of something that failed to compile. We abort this branch entirely. Okay, so that would be then we get the resolved definition, which is called we obtained by calling analyze definition on said definition, and on nothing abort, because we are in the monad. We can just do that, and then with that we can do a pure of from maybe from definition. This internal compiler error is because we've already handled the maybe. Like this is something that is impossible if our code is correct, that our types are not able to reflect. For now, I only have an error here, but at some point I'll have a proper thing of like, you found an error in the compiler, here's how to report it, here's what happens with more information. For now, this is good enough. Okay, that should be everything we need for this, except, of course, we need now to go here. That's perfect. Here, the analyze definition gives us a maybe, but we actually ignore the result, because what we get at the end to build the result of analyzing a module is the cache that we've built. So we don't care about the maybes that are here, and this will actually, this try here is no longer required. since we are already doing it within the analysis now. Okay. One thing I want to check, however. No, this is handled by the fact that we do a run analysis, and run analysis will, even if we've tried things and we've tried to recover from the error, when we do the run analysis at the end to unstack the monad, it will abort whenever there's any error. So that's fine. We will never succeed if something went wrong. Okay, that's perfect. So tell diagnostics, host may be the resolved module. Okay, that's all good, I think. Now the only thing is we probably want to change this. The resolved module here is now very incorrect. Actually, could I get... I kind of want to see... I should probably just get the entire context out of it. And rather than building the result from within the analysis monad, building it from the context afterwards. Maybe that makes more sense. The upside of building it within is I end up having this maybe, and I only get the result if it succeeded, which is nice. Now, I think building it from within is fine. Okay. That means here, we're going to need to build the thing, and we can basically ignore all of the missing definitions, because if any definition is missing, it means we've encountered an error. The result will just be ignored. So it is perfectly fine to ignore missing definitions at this point, because this will only matter if we have succeeded. Okay, so the question now becomes, what do we export from the module? At the moment, since we don't really have incremental compilation, the only thing we have was like the list of things that are defined in this, the list of identifiers, and the cache of definitions, which to a unique name, something that uniquely identifies a thing across all modules, gives its resolved definition that is ready to be used by other compilation units. That is no longer what we need. So those things should not be in this file. This was a very temporary thing. Maybe this is a good opportunity to move them elsewhere. Because we are going to need to preserve a few things. We are going to need to preserve the past definition of functions, of generic functions, because we are going to need the raw definition to be available for analysis when they are instantiated. We are going to preserve the top level scope, because when we rerun the analysis for a generic function that is being instantiated that comes from another module, since we can't really separate the name resolution and the type checking, that means we're going to redo the name resolution, which means we need to know what the top level scope was for that function in its original module. So we're going to need to preserve that as well. So we are going to need the cache of definitions. We're going to need the list of all functions that are part of this module object, which means basically all the functions, all the non-generic functions defined in this module, and all of the generic functions that have been instantiated regardless of where they come from. And we are going to need a cache of generic function definitions. And I think that's about it. Which also means we need to keep track, we need to change our context to keep track of the functions that need to be instantiated. We probably want to do that in a separate phase because we don't need to do that as part of the analysis of this given module. Okay. I'm trying to think if there's anything else I've forgotten. No, I think that's about it. Okay. So let's move this. Actually, maybe it belongs here because this module is just a top level module that calls with everything within the subdirectory and that defines just the top level function analyze module and its result. Maybe after all it belongs here. Okay. Okay, so I think exported is correct. We still want that. That is used for, this is used for import statements. Like, okay, what names are being brought into scope? The definition cache, I think, is correct as well. And in the sense that, like, we will need, and actually the functions need to stay into it. The functions needs to stay into it because that's the thing where, like, a module A imports a module B and calls something from the module B. We need to have access to the definitions. And importantly, something we figured out like a month ago at this point, we need access to the definitions of modules we depend transitively on, even if we don't import them. For instance, module A depends on module B, calls a function in module B that returns a struct defined in module C, and this function in A gets that struct from C and calls a field on it. To check that this field is valid, we need to know the definition of that struct, even if it's not imported in the current scope. So we need to know all of the definitions of everything we depend transitively on. So I think no, this definition cache needs to stay the way it is. However, this is used purely for the purpose of the compilation. I think what we want is the output, the objects, the symbols, which are going to be the things that are to be included. I should have quit Discord before streaming. Let's do that. Yes, the symbols are going to be everything that ends up being included in the binary in the end. And therefore, although we'll probably... that's fine. I was thinking, do we want... to... Sorry. This is the symbols are going to be everything that is included in the binary at the end, which is all of the non-generic functions and all the instantiations of generic functions that this module requires that will be deduplicated at the end when we actually generate a binary. Something I'm wondering is, do we want to cache those across modules? For instance, module A created a local, like, instantiated function foo with int. Therefore, we have a object for a symbol for foo of int in the output of A. Module B also instantiates function foo with int, but maybe we'll need to include it in the object of this module for sure, but do we need to reanalyze it? Maybe we could use the cached version. But if that's the case, that means that the cache we get here, we must also get a symbols cache to be able to reuse. Yes, I think that's what we're going to need. Okay. Well, that's the same thing, isn't it? Unless... because symbols, what do we need to include in the final binary? Functions, obviously. Constants, I guess? Enums will all be inline, so they don't need to. But constants might actually be... it will depend on how we do the code generation, but maybe for a constant that requires to be initialized and to be put in memory requires a lot of memory manipulation, given our target language, maybe we need to treat them as separate symbols that will need to have their own thing in the binary rather than always being inlined. That being said, we do inline most constants. Though I think the only thing we can't really, only constants we might want to not inline are the string ones that we don't support yet. That being said, I think we will want at some point to have symbols be contain also the constants so that we can do this kind of optimization at some point when they are not inlined. So that means, but I think I don't want it to be the same thing where we carry a full definition of the thing. That feels inaccurate. A lot of things that have definitions are not symbols that need to be exported. So maybe we just need to create a new thing, which is what is a symbol, basically. Stacking things on top of other things, as is usual. Okay. So here in representation, I think I'm going to add the notion of a symbol. Which for now is going to be a very trivial thing. Is this overkill? Let me check the AST quickly. For constants, what do we have? We do have a constant info. Okay. Or just maybe maybe that's good enough for now. That's good enough for now. This avoids storing an actual full definition that we don't actually need and purely storing the thing that we actually care about. This is a function, this is a constant, this is the two kind of symbols that we'll actually include in the final binary when we do code generation. Yeah, maybe this is good enough. Okay. Now this is going to require a few things. This is going to require some of those. At the very least AST. And I think that's basically it for now. Okay. Did I name it singular? I named it singular, but tokens is plural. I'll think about it. So we'll need a symbol cache, which is going to be as well just a hash map from name. Okay, the train can be heard, perfect, to a symbol. That's what it is. Now this will therefore also need to take a symbol cache as an argument. And the result of compiling a module will be its own symbol cache of all the things that actually need to be in the binary at the end. That will be the basis for code generation. Structs and everything will not be part of the code generation. Okay. That's not everything we need in the output of a... That's not the only thing we need in the output of a module, because again, we will need to be able, when instantiating a generic function, to have access to its past definition. That is annoying. That is annoying. Because that means we need to maintain a third cache across modules, which is kind of like the definition cache, only for functions, and with the past version instead. That is extremely annoying. Oh well. just function cache? Maybe. Which is going to be a hash map from name to, and I will need the location there again. Can I just use here a function info passed? Probably. Because core. Yeah, this takes a function info. Okay. We're also going to need to modify this function, come to think of it. So many things to modify. Okay. And therefore, this will also take as an argument. For now, I don't have a overlapping monad in which all of the incremental compilation is done. So I have this function that takes all of the arguments manually, kinda. Maybe at some point I'll have some kind of monad state or something that carries the state along, and I will be able to not have everything given like this. We'll see. We're not yet at that point. Function cache is what is required. Okay. Oops. So for now, this should probably already compile despite the changes we've made, except for the calls at the top level. Okay, let's make this compile before we actually do the function instantiation. Which means I need to go to my very temporary rough main. That is the one that calls analyze module. There we go. Okay. So here I am running a very ad hoc monad state that carries everything. And I'm inserting, okay, this is the definition cache, and this is, okay. So here we are gonna need to give analyze module well, definitions, symbols, functions. There we go. And here that means I need to modify yeah, I need to modify the state. So that means the state becomes this. Resolved module here is gonna be like this. I'm gonna just do this so I have the definition there. This file is extremely ad hoc. This is purely to try to run things. We will do something a bit cleaner. There's a main that carries a anonymous double state at some point. Definitely. One, two, three, four. Okay. So here we update the definitions. With the ones I'm gonna, since I don't have the name cache in the others, I'm gonna harmonize all of this. There we go. Symbols likewise will be added will be merged with this. Since it's all indexed by name and name is guaranteed to be unique for a given symbol or thing, then that should be fine. And yes, I think we need that as well. Wait, do we need... Yes, we need the functions, yes. Okay, so now this nonsense should compile, and when it does, we have those caches that are for now unused. We can start doing the function instantiation. Okay, what do we have? Yes, here the type isn't correct. Because first we take the local scope, which is a new thing we've changed, and the scope is this one, the top level scope, which is a hash map. That's the thing we forgot. That's the thing we forgot. That's the thing we forgot. Okay. So I'm gonna fix this first. And then I'm going to go back to analysis. Here, the function cache cannot just be that, because if we want to rerun the analysis for a function that was defined in another module, we need to know what its context was. That is extremely annoying, but that means we need to have that as well. We need to have a top level scope as part of the function cache. That is quite ugly. I'm not super happy with this. But short of, like, again, splitting all of the analysis between name resolving and type checking, which would not be a clean split, that's the best solution we have. That'll rewriting the code a second time in a different context, which is even worse, I think. So maybe that means we introduce an alias for that, just for readability. Because top scope, yeah, this is a... Is that just a scope? Yeah, I think it's just a scope. It is a hash map from path to non-empty role. Okay. So here we can say this is the scope of that function for the analysis. Is that correct, or am I shooting myself in the foot here? Because what I'm going to do is, okay, you're instantiating this function foo from another module with a type parameter, which is a struct from this module that contains fields and so on. Which means that I'm going to have to resolve the function as if it were in its original scope. It can call other functions from its own module and so on. But do I need to have some names from the module in which we're doing this in scope or not? Specifically, do I need to have type names in scope? I think the answer is no. I think this is fine. Because what we will be doing will be saying, actually, this type parameter points to this specific role, which will be probably top level declaration name or something like this, which means we don't need to do the identifier to name resolving. We will always have the name from which we can look up the definition in the cache, which will be there. Okay, so no, we're good. This should be fine. this project desperately needs documentation. That's something I've been hesitating quite a lot. I feel like making a documentation stream is not that interesting. At the same time, I really want to not work on this project outside of the stream, so I don't know how to square that circle. Should I just make an extra stream at some point, which is purely the documentation stream? Should I make like some low effort camera off documentation streams? I don't know. Or do I decide that documentation actually is not what is interesting about this project and therefore I can do it off stream? But no, documentation is part of the work. So I don't know. I feel like if I need to document this on stream, but I need to figure out a way that is interesting to do that, I think. Okay, so change a bunch of things. Let's try to see again if this compiles. Oh, yes, I meant 2 in monad here in with local state. Here I can call that a scope because I've introduced a type alias for that. Okay, let's see. Wait, no, analyze definition does give me a maybe value, right? And this has to be in the monad. Yep, perfect. Oh, unless I forgot to fix the signature of analyze definition, I might have. No, it does give me a maybe value here. Is my definition of on nothing m wrong? On nothing m, I have some monadic maybe a and some other maybe a returned maybe a. Yeah. Okay. Oh, of course. That's because I'm not using. Yeah. This, I think this being completely wrong is why everything else was not compiling. Let me see. Okay, so now we have at least better error messages. Okay, so it's saying that this is actually an analysis of definition resolved, which to my knowledge is not correct. Because it refers to this one. Oh, I know what's happening. I know what's happening. I have a boot file in which I did not update the signature. There we go. There we go. That should fix it. Okay, location with location not in scope. Ah, that's because... Yes, I see. So here I still need to do get the resolved definition here. And then return with this thing. Now, there's going to be the question of also here, I'm going to need to update a few things. I'm going to need to add stuff to the symbols and everything. I might do it as part of the analysis here, I think. Since the cache needs to be updated with the maybe value just to be able to know the things we've tried and failed to analyze. The other caches don't need to be populated if we fail. So this is fine. Okay. Couldn't match. I guess we seem to have the maybe in the wrong place. This is a maybe with location definition resolved. Oh, yes, of course. We need to remove the location within the maybe. Okay. Pure resolved definition. This is the same problem there again. Ah, yeah, I'm recreating the with location to put it in the cache, and then I have to remove it again. That's kind of ugly. Oh well. Wait, I do have access to the where's the definition? Yeah, definition is right there. The location here, I don't need to do that in this. I can do it here in this scope, which means here I don't need to return the, I can remove all of this. Which means now I have the result definition that does not contain the location. Here I can put the with location of the def location of the result definition, and here I don't need to do that. Okay, that's better. Except, of course, this is a maybe value, so this needs to be f-mapped. Okay. And now core compiles. We're just missing a few things in this file. Okay. And that's because I simply have not named the arguments here that this new function now takes. So foreign definitions, do I want to use that? Yeah, that seems fine. Foreign symbols, which is a cache, and foreign functions. Okay. And yes, of course, here the problem is we are constructing this resolved module that is completely wrong since we have now changed it. So let's do that. We're going to want to export all of this. For now, since we don't have any of this, it's going to be enough to just put empty things for the symbols and functions. That's fine. So now we can absolutely do this for now. The only thing is, cache definitions isn't correct. What we want is a cat maybes for hash maps. Because our definitions is currently a maybe with location definition resolved. And we want, excuse me. Yeah, so we just need a hash map cat maybe. And I don't know if this exists. It doesn't. Okay, that's a good candidate for something to add to my prelude. So let's do that. Let's stack something else on top. we are gonna want a cat. Is it cat maybes? What's the one name? The one in list. It is cat maybes, yeah. So we probably want some. Actually, could cat maybe be generalized to any traversable? There's no reason it could not, right? No, actually, it modifies the structure, so no. Okay. How do I name this? Hashmap cat maybe is ugly as all sin. Something I could do, a thing I've seen in some other projects, is to re-export my own internal module called data hashmap strict that re-exports the other one and adds my own functions, which means the functions I define for that module, the extra functions, will be in the same scope. That might be the best option. Yeah, I might do that, I think. Which means here this becomes import this. Wait, if I do that, does that mean I have to tag every single one of them? Yeah, probably. So maybe I don't want to do that. So instead, maybe I will call it extra. But it becomes, I still think it's better to have it like scoped within the name here. So I think I'm gonna do that. Yeah, okay. So basically I have here in common now, beyond the prelude, I'm gonna have extensions to third-party libraries. I think I still would prefer to have a name that clearly establishes that this is not the original. Just beyond a extra suffix. I'll think about it. This will be somewhat similarly to the prelude. I'm gonna be doing this. That's the okay, yeah. So this re-exports everything from the hashmap strict module. But this will also now contain my extra functions, and this will contain a cat maybes. That given a hash map also, I think I'm just going to do that. A hash map from key value, maybe value, will create a hash map key value. Cat maybes will be, what can I use that already exists in this? Is there some kind of map maybe already? There is a map maybe. Is it just a map maybe ID? It is, isn't it? It is a map maybe ID. Okay. It's still nice, I think, if I want to add more functions that are specific to hash maps that with a name that needs to be scoped, I think having this in place is not a bad idea. Okay, so now here I'm importing extra instead, and I can do cat maybes of the definitions. Wait. Huh. I've never encountered this before. I thought it would be obvious that the thing being exported is the one defined in this module, but I guess not, yeah? Okay, there we go. Now, oh, those are the lenses that are being exported. I could probably just export everything from this module. Yeah, I can just probably export everything from this module. There we go. Unused matches. Those are warnings as errors. We like seeing those. It means we have resolved everything else. Yes, here we are gonna want two. This is from definitions, I believe. Yes. And I probably want. Okay, already done. Okay, and now this compiles. Almost, except for the main, which doesn't. What do we have here? This is an exec state T, which means it returns the state. And here I only care about the definitions for now, so I need to pattern match like this. For now, this main is again extremely basic. It takes a list of arguments and compiles the modules in order. Doesn't try to do a graph of dependencies, anything like this. All of this will be done at a later stage. Okay, so the very basic text we have pass, and this compiles. Okay. How do I break this down into individual commits? Do I bother? Because a lot of it, yeah, it's gonna be difficult to do. A lot of it is basically just changing. At the core of it, if I may say so, is this change where we've introduced with local state instead of reset state, and that has changed how we do error handling. And everything else is a consequence of that. So I think, since again, until I'm in 1.0, I'm okay with not being super strict about commit history, since we're just like everything in a dev branch. When we have something that actually works and we do incremental changes, I'll be a bit more strict about them. For now, I think I'm okay with not being super strict about commit messages. I think this is fix state, fix context being reset in recursive definition analysis. Although I have forgotten to add uh, this, this, and this. So let's amend this quickly. There we go. Okay, now we have committed this. We have a somewhat clean slate on which to actually use this thing and populate them. So here, what we're gonna need to do is we analyze all of the local definitions, but we need probably to keep track. I guess I could stack them. There is no reason, since I have this local scope thing and now, there's no reason not to. I thought I would have to like, okay, I'm in function foo. I find that there's an instantiation of function bar with int. I register that as a function that needs to be added to the that needs to be instantiated. There's no reason not to do it recursively. That way, I have the benefit of if it fails, then the cache will be populated with a version that is not except the cache is not used for generic functions. But there's no try at the top level, which means but it's still gonna be Do I want to recursively do the function instantiation, or do I want to do it at the end separately? Huh. Let me think about this. I think it makes more sense to do the instantiation recursively. I am looking at a function. I discovered that another function needs to be instantiated. I don't want this local function to succeed if the instantiated function does not. That makes no sense, I think. So I should probably recursively. Yeah, I think it should be recursive rather than maintaining a cache of things that need to be called. Okay. Okay. Except no, I cannot. Because of recursive functions. I need to be able to delay instantiating the functions until I'm done analyzing the functions in case some of them are mutually recursive, and instantiating them. No, it should be fine. It should be fine since calling a function doesn't require actually doing the full analysis. But no, if I have mutually recursive generic functions, I'm still going to try to do the full analysis, and therefore I'll have a dependency cycle and it will break. No, I cannot do the things in line. I will have, this is extremely annoying, I will have to keep track of which functions need to be instantiated. The easiest solution is just put it in some kind of cache in the state of my analysis and do it at the end. The downside of doing this is that the error messages will appear somewhat out of order, which isn't great. I guess I could try. There is one case where I can for certain instantiate a function even if it hasn't like inline, and that's when it's one from another other module. If it's a foreign function, I can do that. Because then there's a guarantee that it doesn't depend on anything that hasn't been analyzed yet. And that way, the error messages will be a lot more consistent because I'm error within function foo, error within function foo, instantiating function bar, error. So that's better, I think. So we want to do that. Okay. So let's add a few things. First, I will need in the reader thing I might just actually put those not here, but here. So the foreign definitions are the definition cache. Is the symbol cache. And the function cache is the foreign functions. Is the function cache. Okay. Now this needs to be properly initialized. Which is here somewhere. Empty here makes sense. Actually, I don't know why I have those lets like this. I can just do that. There we go. Foreign definitions, foreign symbols, and foreign functions. Okay. Now, for local functions, I will not be able to instantiate them as I find the instantiated call, which means I will need to register them. And there's going to be a slightly tricky thing, which is that when I do actually at the end, when I go through the ones that have been registered for post processing, I go through them. Some of them might register some other ones for post processing. So I'll need to make sure to, when I do here the generation of them, I need to make sure I maintain another cache to avoid duplicating, to avoid going through the same thing twice. Okay. Okay. Okay, so now we do initialize the reader scope with the correct stuff. That's fine. So now what I want to do is I probably want to go to instantiation. And add a new function, which is going to be instantiate generic function. What it's going to need is it's going to need the name of the function, I believe. That's going to be enough. Its unique name to do all the lookups in in those caches. Okay, it's this function. And it's going to need the new list of types, which will be made part of the name. But I guess I don't need them to be names. What do I need them to be? Or rather, if I go to... I guess it's a list of role, as in the thing that points to what the past version of that thing is. Because I believe that when I process a generic function, what I do is to the identifier, I associate a role, which is template parameter. So, and yeah, basically what I do is in my scope is a hash map from the path to a role. Okay. So I will need basically a list of role, which is for each template parameter, what is the corresponding type that we actually want. And hopefully all of those, actually no, I don't want those to be roles. That's too generic because I could be passing something like, no, actually I do want role because I need to support either a built-in type identifier, or a top level declaration. At this point, it should always be one of the two and never a type parameter. I can probably check that. But yes, I think I need a role. So I get the name of the function, I get the role, the list of roles, and this will return within the analysis monad maybe of a function info resolved. Does this even need to return anything? It might not even need to return anything because I will just update the corresponding caches. It's just about putting the proper version in the symbols of the thing. So maybe this returns nothing. Okay. So we have the name of the function. From that, we are able to get the original past definition by looking at the info foreign. That will tell me whether. This will tell me whether if it's in the foreign functions, it is therefore not a local one and it can be instantiated. Otherwise, so I have two options here. Do I try to make the same function be useful in both cases? I don't think I want to do that. Okay, so no. This is instantiate foreign generic function, where we know this is the case for which we know this is a function that was defined in another module. Okay. So here I get the cache foreign functions, and what I do on it is going to be a lookup of the name, and on nothing m, that means we are referring to a function whose name we know, that we know from the color that is was defined in another module, and yet it isn't found in the cache. That is an error within our logic. That's not an error from the user. I think this is a case of an ICE. Although for now, this is just an error like this. But we do get the past definition. Okay. And in fact, we do get the top level scope and the past definition. I guess I could I could start with the case, the generic case that's going to be true for all instances, which is we don't have the name, we have the function info past. We have the function info past. And do we need a top level scope? We do need a top level scope. So scope function info past, the roles, and this does the thing. Okay. So doing the thing here means calling analyze function definition with the definition. And this is where we're going to deviate. This needs to take the parameters, and we don't have that yet. This gives us, and we need to do that in a with local scope, with local state top level scope, analyze the function. This gives us maybe the resolved definition. Now, we have potentially, if this worked, if there was no error, actually instantiated the function properly. Now, what can we do? What must we do? We need to put it in the symbols of this. We need to put it in the symbols of this module. So, context symbols, I believe. Aha, I don't have that yet. Which is not a definition cache because it's a maybe. But I do have context symbols now, which are going to be the symbols. And I probably, do I want to have? No, the function cache doesn't make sense for this. Okay. Okay. So here, context symbols. I'm going to add I'm going to need the name of the function. And the resolved definition. But we only do that if it's if it's not nothing, if we do indeed have a definition, if it succeeded, we can do that. Okay. Now, this ignores a big thing, which is we need to look into the cache to avoid analyzing functions, instantiating functions that have already been instantiated by other modules, because that's useless. So we need to do a view s of the info foreign symbols. I also need to check the local symbols, I suppose. That's fine. Okay. Is there a way to do... No, there isn't. Okay. So I will apply a function here, which is a lookup of the name, which I will need anyway. And if it's just some symbol, I guess we don't have to do anything. We don't. No, actually, we do. No, we do want the definition because we do want to insert it into the symbols of this file. So no, we do want it. Okay. So we will want the symbol to insert will be the result of doing this. And on nothing m, we're gonna use context symbols to see whether it's already in the things we have already defined to avoid doing it twice. If it's still nothing, then we do that. Which will reinsert it if we already have it. That's no big deal. At least we're not redoing the analysis. Okay. And now this one can be simplified because okay, I'm going to introduce a local function for this. So where run analysis will be this thing. We get the definition from the analysis. It will be a maybe definition. And on nothing here, we will abort because it means it failed. It failed to compile. And then we do have the definition, and we can return a function with the resolve definition. Wait. This function. Yeah, it gives me the function info. Okay. So this is fine. Now we just need there we go. Okay. So now we try to get a symbol that has already been cached in another module. If it fails, we try to see if it's already defined in this module. If it fails, we run the analysis. Like we need to instantiate that function. It hasn't been instantiated yet. And this cannot return nothing because we are using the abort. Although I'm tempted to put it here for readability. Oops. Get the foreign symbol, or get the local symbol, or run the analysis, or abort. We couldn't find a symbol. And that just means here I need to do this. Okay, I think that's somewhat readable. And if we did an abort, we do have a symbol, and we insert it in the local cache. So that's the instantiation thing. Now, we are going to want to distinguish between trying to instantiate inline if we can, otherwise delegate, and process a delegated function. Process a delegating function will be this. So I guess I just need another function, which will be here, which will be this which will be this. How do I call that? Do I call it try instantiate? Yeah, I think that's a pretty verbose but very explicit name. Try instantiate foreign generic function with just the name and the parameters. And what this does will be we try to get the definition of that function in the foreign functions. If we find it, if we get a scope and an info, then perfect, we can instantiate it. And that means, oh, I'll need as well, full name isn't defined here. I'm gonna need to define what the full name is in a second. Oh, this is another thing. Okay, there's something else I need to fix. So many things to fix. Here we can call instantiate generic function with the scope, the info, and the params. Otherwise, this is the case where this function we're trying to instantiate is local to this module. We can't do that until we have finished passing everything in the module to avoid creating circular definitions. And therefore, we're gonna delegate that to a later stage, which means probably putting it in some kind of set of things to process at a later stage. Okay. Which will be, we don't have anything for this yet. What do we want to track across the module? Which is just going to be a hash set of name, I suppose? Well, not exactly, no. It's going to be a name and a list of role. Yeah, I think that's what it is. Okay. I guess I could also put a copy of the function info there. I could put a copy of the function info there to avoid having to do some lookups in the local definitions. That being said, there's no point in doing it. I'm gonna have to do it anyway. Maybe let's do it when I do the instantiations that make maybe more sense. Okay. Okay. So I need also to add after scope. I need to add a context instances, which is going to be empty. There's another issue I realize that I will want to move, I think. Stacking another thing on top of the other things I was already doing. When I do analyze definition at the top here, I do a few things such as setting the location of the thing I'm analyzing and setting the name of the current one. And I probably want to do that in the local state as well. And I probably want to do the location as well. Because I probably want to be able to, if I'm stacking things, I want to be able to get back to the location where I was before. So the local state needs the top level scope. It needs the root name. And it needs the def location. Okay. We can remove this. Yep. And this, and go back here and go back to with local state. There it is. We add this to the things we're setting for the context, which is here's the location, here's the name. In which order did I give them? I gave them as scope, root name, location. Okay. Okay. So those three are now set as part of this function, and I need to restore them in the same way that I restore everything else. So I am going to need to... It's almost tempting at this point to just... to get the previous context, actually, rather than doing all of this nonsense. Oops, icon type. Like, let's get the entire context. That way I get the copy from before. I do the result, I set the things, I call the action. And then, rather than restoring a bunch of things like this manually, I need to remember to reset the ones that need to be reset, I can do a modify that to a given context will associate. And here I'm just going to use this syntax, and I will need not all of that, of course, but I will need everything that has been overridden, which means the cache isn't changed, the scope is, the instances are not, current is, location is, fun type within loop, any error, new error, any error isn't. There we go. And I should be able to just use this syntax. Hopefully, that should be fine. Let's see. If I try to compile now, I'm going to have so many errors. It's still worth a try, I think. Symbol is defined in stage analysis symbol. Does it not exist? Oh, yes, of course. It's in representation symbol. Deriving show. Yeah, that makes sense. So let's go back to symbol and add a deriving show. And this is why I wanted to have the prelude. Okay. Yes, it's no longer called context cache. It's now called context definitions. Also, I'm noticing that there's no longer any need. I wonder why stylish Haskell didn't fix that for me. Okay. It's missing, of course, context symbols. Which is, of course, gonna be empty as well. Okay. Here. Oh, yes, this is not a hash map. This is a hash set. Oh, I thought I had a hash set in scope. Oh, I do, but I never actually do anything with hash sets in this module. Okay. There we go. What next? With local state, yes, I have not fixed the signature of this thing. It takes a name and it takes a location. This is likewise in representations. Oh, it didn't even reorder. That's bad. Pass error, yeah. Oh yeah, because I didn't finish this. That's fair. Defined. use. Yeah. Okay, so now we have the problem of full name. We're back to at this basically. Okay. So here, this is the one where we try to instantiate a foreign generic function. And if we cannot, that means it's not a foreign generic function, then we need to register it as something that needs to be instantiated later. So that's the thing we've just added in our context, which is this instances thing. So this will be a context instances that will be modified by doing an insert of a tuple of the name and the params. Anything else we need? Nope. Perfect. So in this context, we have instantiated it's fine. In this context, we have registered it for later because we have to defer the instantiation. Okay, here we do the instantiation. And we always have the name, which is the name, the unmangled name that doesn't contain the arguments. So now we need the actual full name, which is going to be the full path of the name and the name of the parameters. Wait. Which means I have to be able to identify a unique name for each rule, which is fine, and is a way to actually check that when we are trying to instantiate something, we do have arguments that make sense. Because we need to be able to point to arguments to actual types somewhere. Which means we need to get either a built-in type or a top-level declaration. Those are the only options here for a name. Okay. And this can be an internal compiler error on failure because we will only try to instantiate functions when we have verified that the things we have are types. So we will already know that they're valid. Okay. There's one thing that bothers me is for built-in types, I have an identifier, which means I will need to find. It means I don't have a name for. I don't have a name for built-in types. Oh wait, I seem to have one. I'm wrong. No, this is a rule. This is a rule. Ah. That means that here I think I should change this. I should change this to be a name rather than a identifier. Which means in turn that here those built-in types need to have an actual unique name, not just an identifier. And that's not, I think, too monstrous because all names will be a non-empty list of identifiers, but for all things defined in code, this will contain the module and then the identifier, so that it can uniquely identify the thing within a compilation. If I just make their name the root thing, that's perfectly fine. Okay. So that means this is now a name that contains pure of whatever was given here and an empty list of parameters. Okay. Okay. Having the parameters in the name and in the path info is a bit redundant. That's a bit ugly, but it's fine. Okay, so now we do have a proper name for built-in types. We can go back to instantiation here. So now the full name will be a name which contains the name full path of the original name, but also contain a list, which is the list of names, which for each role in the parameters, case role of, either it's a built-in type with a given name and it's that name, or it's a top-level declaration and it has a name. It's that name. If it's literally anything else, we have some big error in the code. This will be a nice. Okay, and that gives us a list of, and that gives us the full name. Perfect. Okay. This should be fine. So now we have, I think, everything we need. Now, whenever we encounter a call to a function, in the analysis of a function, we can try to instantiate a foreign generic function. If this fails, well, it will either actually do it or delegate it, and at the end, we can instantiate all of the local functions that we have found to be instantiated in this module. Okay. What are we missing here? We are missing one big thing, which is that analyze function doesn't take the parameters. We need to fix that. And we probably need some helpers to help with like, hey, is this something that's worth instantiating? That will be something that's going to require not the full function info, I believe. Yep, it only requires the function type. Do I have the name in this? I don't. I will need the name. No, actually I don't. Okay. So I have the function type. which tells me whether this function has generic parameters or not, basically. And I will have a list of role, which is the things. Do I have a list of role? I don't, do I? I have a list of path info passed. Because the types within the arguments might themselves have type arguments. So this will be a path info passed for sure. Resolved. This will be the types that I have here, that I know are types, that I have validated to be correct. But as a result, those are not just directly roles, they are actually... Okay. So this is going to make this thing a lot more complicated. That's fine. Okay. Okay. I can still do that, and this is a pure Boolean. Can instantiate for a function type and for some params is going to be a very simple thing, which is it needs to have generic arguments. It makes no sense. It makes no sense for a non-generic function to be instantiated. It will already be fine. Or I suppose I can instantiate in the sense that I can register it, I suppose. But I think here can instantiate is like, do I want to instantiate this thing now is what I want, I think, to... I think I'm going to try is generic, which is the first step. Oops. Given a function type, give me a Boolean. And that is very simply it is not null of function of func type params. Okay. Can instantiate is generic function type and length params equals length fun type params of the function type, which means we have provided... Hello, sorry, I hadn't seen your message. This evening, since on Tuesday we kind of finished the analysis of functions, what I want to do this evening is to wrap up the analysis of a module. And specifically what I'm doing is the instantiation of generic functions. The way my generic functions work, since the language doesn't have traits or anything like this, whenever we try to analyze a generic function, any type checking that involves a type parameter, a template type parameter basically, is ignored. Like, yeah, the type T, whatever, it has all the fields in the world, it is compatible with all operations. We short circuit the type checking for anything that involves a type argument. And we are going to do the same thing as C++, basically, which is we are going to generate a new symbol in the final binary for each instantiation of a generic function with a given set of type arguments. We'll try to deduplicate them. If they end up having the same bytecode, there's no point in having them twice. But in theory, we'll generate one symbol for each. So there's a function foo with a parameter t. We'll have a symbol for foo of int, a foo of car, foo of boolean, foo of whatever. And each module will contain, as part of this result of the compilation, of the object file kinda, will contain all of the instantiated generic functions that it requires, whether they were defined in that module or in one of the dependencies. So it's able to link basically everything it needs. Like it doesn't depend on those functions being instantiated elsewhere. So now what I'm doing is I am doing the complicated task of we have to mangle the state of our analysis to be like, okay, actually we need to step back into the context of that module where the function was defined to reanalyze the function all over again now that we know what types are given to it. And it's been a lot of reworking how the state is being passed around in the analysis of a module. And now I'm at the point where like I can start trying to call instantiate foreign generic functions and so on. And I'm just trying to decide, is this function call I have found something that needs to be instantiated? And the answer is yes, if it is a generic function. And there's a parameter given to every single argument. Actually, I probably don't need to check this one because I already fill up with placeholders if it's not. So that check is not required. However, I need to check that all concrete the arguments that were given. What does it mean for a type to be concrete? Well, it means first the role has to be either a built-in type, that's concrete, that's fine, or it needs to be actually at some point some built-in types will have type arguments. So it needs to either be a built-in type or a top-level definition. Those are the only kind of types that can exist. And its type arguments, the arguments to the type itself, must also all be concrete. Yes, I think that's correct. Okay, so that means it's all is concrete of, what's the path info again? The path params, and case of the path name, which is extremely poorly named because it's not a name, so it's often a role or an identifier. And this needs to be either a top-level declaration, in which case... Oh, do I do this as part of the new name? Because this is going to be the same thing I do here for the name generation, kinda. Nah, I think it's fine. Okay, so this is true. If it's a built-in type, that's also true. And otherwise, if it's literally anything else, nope, that is not a concrete type that we can instantiate with, because it means it's a type parameter or placeholder. Okay, so this tells us, hey, this thing we found, this function call we found, is it something that can be instantiated? If it is, we can try to instantiate it, which looks at foreign functions. If it was defined in another module, we can absolutely instantiate it right now. If it was defined in this module, we can't instantiate it right away. Like we have a function foo that calls a function bar defined in the same module with an argument that we know is concrete because it's an int. we still cannot instantiate it right away because we would stack the analysis, the full analysis of bar on top of the analysis of foo. And if bar calls foo again, we have a cyclic definition. So we have to delay it. In the case it's local, we put it in something in our context to be instantiated at a later point. Now, here, this name generation is incorrect because I don't have roles. I have path info passed, which is pointing to some type and giving the type arguments. Which means I will need to resolve all of that. Which means I need to do the same thing here, path info something. Okay. And based on the path name, that gives me the name, but that's not... Yeah, okay, I need to make this a function. Okay. Generate full name or mangled name or whatever I want to call it. It's basically like the full version of the name of the function that contains all of the type arguments as part of it to differentiate foo the function versus foo of int, foo of character, so that they all have a different symbol name basically. This is something that, given some original name, creates a new name, which has the full path here, but then puts the argument. And arguments are only ever used in names for functions. This is fine with types. So this gets each path info of the parameters of the types we have given as argument. We must have already verified that they're correct. So here I can just error if they're not. So here I get some name n, whether it's a built-in type or a top-level declaration. Yes, I need the parameters as well, of course. And this would be... There we go. Type parameters. So now I look at the first part of this, which is what this points to. It points either to a built-in type or a top-level declaration. And here we recursively generate full name and with the path params. There we go. Okay, that should give us the full name. And then here we can try to see if it has already been instantiated in another module as part of this compilation, get it from the cache. We don't have to reanalyze again. See if it has already been analyzed as part of this module so that we don't do the same thing twice for local things. Otherwise, we run the analysis. And if the analysis fail, we abort. Okay. The only thing is, does analyze function actually, is that correct? Actually, analyze function doesn't tell me. It always gives me a function resolved. So I don't actually need to do this abort. I will always get a thing, because I can always generate a sham in the worst case. It just means the module will fail to compile anyway if there was any error in it. That's fine. The only thing that bothers me with this is... Nah, that's fine. That's fine. That means I am in a function foo. I see that I'm calling a function bar from another module with a parameter which is concrete, so I can instantiate that generic function bar from another module. I instantiate it. I run the analysis because it wasn't in the cache. It fails. I get an error message for the instantiation of bar, but that means I recover and I can continue analyzing my calling function in case there are other errors to find there. It's not the worst. Okay. So this is even better. And I can therefore simplify this quite a lot, because this is just function f mapped into this. Okay. So now we have this. We are missing only one thing. Well, we're missing calling those functions, of course. But we're missing, for this to compile in the first place, even if we don't call them and they're not used, we are missing the fact that here I am calling analyze function with the parameters, and we do not have a way to do that yet. So, back to core. And here at the top level, when I analyze the definition, here I might need to do something different for those two. So I'm gonna get the resolved info, which will be the result of calling this. And then I will do some shenanigans at a later stage and then call pure resolved info. I'll actually pure const def of that. For a function definition, likewise, I don't know, it's not aligning properly. Analyze function, and we will do some shenanigans because we will need to register the function. Like, there's functions and constants are the things that end up being symbols, so we're gonna have to do something a bit different for them. And at some point, we will just return pure function definition of the result of this resolved info. The difference here is here when we are analyzing the top level function of a top level definition of a function, we are not giving a list of parameters. Should that be a maybe, actually? It should. It should be a maybe. So this is nothing. And here, this is just params. Okay. So I'm going to rewrite this as being fmap of s function on with local state top level scope. Oh, this is missing a bunch of things now. This is wrong now. Of analyze function definition of just the parameters. Okay, but now with local state is missing a bunch of things because we've changed how it operates. Because now it takes the scope, the name, the location. Okay. So here, scope we have, name is the original name of the function, which is going to be used for error reporting. So it's not the full name, it's the original name. And I need the location that I do not have. Of course, yeah, I need that. So that means I'm gonna need to change a few things. Okay, so the function cache does have the location, so I will have access to the location. Okay, that's good. So that means I can probably take here a with location function info passed, which means here this info. Actually, what does analyze function take? It takes a function info. Okay, so this will be a with. I don't want to deconstruct it here. Located definition. Let's be explicit. And so here I need to call name, and here this is the location of the located definition. And this is the thing that is located, the definition of the located definition. There we go. Now that should be correct. Okay, and now the last thing to do is to go back to the analyze function and change this to now contain a maybe list of path info resolved. Shit. In my scope, I will need this to be a role. Because when I do a lookup of the type parameter t, I need to find the exact type that it is. But that exact type will not just be a role, it will be a role with parameters. Oh no. Oh no. Okay, so change of plans then. Because my plan was this. My plan was here I have this set type parameters function, which is called on a bunch of different types. Which checks a bunch, which like does some basic checks on the definition of the type parameters of a struct or a function, that none of the names of the parameters are actually, reserved parameters, that none of them are duplicated, that they don't shadow anything else in scope, that kind of things. And then I put in the scope something that says, hey, this name, the name of the parameter, matches to a type parameter. This is what its role is in the scope. However, here, what I'm saying is, when I see the name t, I should always instead see it as this resolved type. Which is not something that is just a basic role mapping. Oh, that is frustrating. That is frustrating. Could I deduplicate names and path info resolved? I don't think so, no. Because maybe I could. I have this thing where like the name contains the no, I don't want to do that. I want the name to not contain yeah, no. No. I can't do that. So that means that what I need to do is add another thing in my function specific context, which I should really like make a subset of the current context rather than having a bunch of fields in the context. Or even stack an additional statement on top just to make it very distinct and avoid all of that nonsense I'm doing with local state. I need to put in the local scope for this function, this is what this type parameter means. And whenever I look up a type, if I find that the role of t within the scope is type parameter, check whether there is a mapping for it in the function context. Like, yeah, I know in this context that t happens to be int. That, I think, is the simplest solution. Okay. Okay, because it's the one that allows me to not rewrite all of my role and naming thing. We can probably skip this, however, because it will already have been done by definition by the time we reinstantiate a thing. But actually, we do want to do it because we want this context scope. We want it. Yeah, okay. So no, we want to do that. Which means we're just going to simplify a few things. That's the upside. And I'm going to make some others more complicated. Okay. Yeah, this is wrong and I need to change it. Because in this analysis context, there are things that are specific to a definition, such as current, location, and so on. And there are things that are shared across the entire analysis, such as definitions, symbol, instances, and so on. Which means I should probably split this, and this will also fix my with local state that gets a copy of what we had before, and then do the result and then reinstate everything that was the local state, basically. Do I want to stack more things on top of what I'm already doing? Kinda. Kinda. The problem is I don't want to make it a double statement add. I don't want this to be like a state on top of a state. But maybe the simpler solution that still preserves some of that is to split the analysis context into two different records. One which is, or rather, extract everything that is specific to a function into a new record. I think that's better. And I think context becomes the thing that is contextual linked to a definition. And this becomes the analysis state, which carries the thing that must be preserved across different thing. So definitions, no. But this, no, actually, definitions, yes. Definitions, yes. That's the cache of the things we have defined. Symbols are the things we are inserting in the symbol table for that module. So yes, scope, no. That is per definition, and always reinitialize to the top level scope of whatever thing we are trying to analyze. Instances are in the analysis state. That is the thing. That is the list of things. It's a set of things we need to process. It is a state. It is a set of things we need to process at the end of the analysis of the module. Current is completely specific to a given is completely specific to a given definition. Location is as well. It's not preserved between things, it doesn't make sense. Fun type doesn't either. Within loop doesn't either. Okay. So now I can remove this. Definitions, symbols, and instances, and I'm left with the context. And now in the context, I can add something that is function specific, but that's fine, and that's the params. And those params are going to be a hash map from identifier to type to path info resolved. Okay. The initial context becomes the one at the top level. I am even gonna go one step further. Say that the state, so that the state must contain let's go with module actually. Well, unless I have something called module in the AST, which I do, I think. Yeah, okay, that's fine. It's somewhat unintuitive to have the prefix here not be the name of the type. I think that's fine. Module context. And here, that is a lazy analysis context. Why am I making it lazy? It means that rather than using some thing that are nonsensical, I just don't initialize the context at all at the top level. Initial state. And trying to read it will be an error. Okay. So, initial state becomes basically the same thing, but I keep only definitions, symbol, instances like this. Yeah. And everything else here becomes module context, and that becomes, being lazy, an error, which will crash if evaluated, because it should never be evaluated outside of the context of a definition. Okay. And now, with local state becomes something a lot easier. It becomes with context. And it takes, as an argument, an analysis context. And what it does is get previous context, which is obtained with uses module context. Then it sets the module context to what we have given as an argument. Then it runs the action. Restores the context. And return the result. And that way, we don't have to make this complicated differentiation between the fields that are the global state that must not be identified. And this is the stuff that is specific to every definition that we're gonna try to analyze. The top level, its starting scope, its name, its location, the function type, if any, which is something that we will probably set as part of the. That's fine. The parameters, if any, and those which will always be false. Oh no! Wait. Those are part of the state. They're absolutely not part of the context. However, this one will always be false. So I can probably make a smart constructor that sets it accordingly. Okay. Okay. So those two are important. I'm going to move them here and here. Oh, I need to add them to my state after removing them from my context. Those are basic Boolean. They are my extremely ad hoc error handling and recovery, which can probably be improved. Okay, that's better. And now, with context, I guess doesn't have to take the full analysis context, can take everything that's needed for this and just create it. Yeah, and that way, yeah, I think that's the easiest way. Okay, so this doesn't take the full context, this takes the scope. The reason why we're giving it as an argument, it could be taken from the reader monad, but for function instantiations from other module, we need to restore their scope. So I would rather give the scope as an argument. The name, the location, where does this definition start? And that's it. Everything else, this will be set by the function if needed. Likewise here, and this is always false. Okay, so we're back to having scope, name, location. Just means our context is going to be an analysis context where context scope is top level scope, context current is current name, context location is going to be the definition location. The context fun type Where am I using the context font type actually? Ah, yes, of course. I use it in the analysis of return statements because I need to compare the type of the return statement with the type of the return um, of the function. But I guess I could do this from maybe unit type at a later stage and therefore make this a maybe here. That probably would make more sense. So this become context font type a maybe path info resolved. There we go. So it can be nothing here. Context params. This is a mapping for the type parameters when instantiating something that defaults to MMT for most cases. And finally, context within loop is false. Okay. My only fear is since I'm using a monad, a strict monad, is there a risk that this get the previous context will try to evaluate this one? We'll see. I don't think so because the state is strict, but within it, the context is lazy. So I think it's fine. But yeah, this is definitely better. Okay, so now I need to go fix a bunch of things. We go back to core. I need to fix so many things. First, this is an analysis state here, not context. Which means this is not initial context, this is initial state. Okay. What that means is when I do the analyze definition here, this is a with context. There we go. Which I actually wonder. No, I want to do this because I want to set the name and the location of the current so that if there is a cyclic definition, I will, when I do the thing where like throwing an error actually fetches stuff from the context to get a proper information, this will get some context. Ooh, that means I need to have a context for errors thrown at the top level. So I cannot do that. I need to have some very basic context. Because at the very least, I need to. Can I get stuff from the analysis info actually? What's a module name? It's just that, okay. There's another solution actually, which might be a lot better. I don't know why I haven't thought about this before. Which is that instead of doing this thing where I restore context and everything, I just stack them. Just stack the current one. The only downside of this is now every time I will need to define a bunch of lenses for the context that actually point to the current one. But that's so much better. That means all of my areas at the top level can check and like, oh, we don't have a current context. The stack of context is empty. That means we're at the top level. Use that for the error message. Or I guess, yeah. Yeah, I think this is gonna be slow and a long process, but I think this is the right approach. This is gonna be a list of context which starts empty. And this with context simply well, module context will be modified by pushing the context on top. I don't need to save the previous one. I just try the action, that's fine. And then I modify the context again by doing a drop one, I guess. Is it drop? I haven't worked with basic lists in a long time. I was never gonna compile. I should have made a regular GHCI. Yeah, okay. Okay. So that's a lot better, but that means that I cannot use make lenses for the analysis context. And I'm instead gonna have to declare my own lenses. Context scope. To the point that I actually am tempted to name them not context but current. So, current scope will be a lens from analysis state to scope, and current scope will be module context at 0. Actually, I will need those lenses, but I'm going to introduce those current that will do the at 0 context scope. There we go. Current scope. Scope name. Current name is a lens from analysis state to name. That module context at 0 context name. Yeah, that looks good. Location should be the same. this one will need to be done a bit more manually because this is a maybe path info resolved. Params will be to a hash map of identifier to path info resolved. Is that a scope? No, it's not a scope. Which will be context current params. I'm only concerned about this maybe returning a maybe, and I'll have to do some shenanigans to make it partial. That's just a boolean. Okay. Now, I think the problem will be that those lenses will be... Let's have a look at the documentation for lenses. This will be... It's probably an indexed one. There we go, that's probably what I want. At a map-like container. So that's probably... Oh no, at 1, okay. So that's good. Wait, no, this is a association list. So I want an index version at... Oh yeah, no, that's not what I want. That is not what I want. I want the index. I want this IX version. Okay, yes, that's what I want. However, it is gonna be... It's gonna give me a maybe. When trying to read, this is gonna give me... Oh, wait, no, it uses this operator. Okay, so... Let's try this. I would want control lens at. Okay, I don't have it at the system level, so I need to do a stack GHCI. Let's try again. It's gonna take a while. Okay, so... Okay, what I want to try is... If I have a basic list of string, and I use x1, it gives me an empty string. Oh, because indeed there's nothing in index 1. Index 0 would be foo, yeah? And the index 1 would be... So it needs to be a monoid. It needs to be a monoid so that it can... That's annoying. And if I do this version, does it require... It doesn't require the monoid. Okay. Because then the index is... Okay. And this is where my knowledge of lenses starts to hit a wall. Because I will want something. Because I will want something that forces this to be. I want a lens that unwraps the maybe, and I am okay with it failing on air, basically. Because now this becomes those at zero all become instead become x0 at index 0. There might actually be some lenses for lists specifically. Traversals, possibly. Like what I want is the first, basically, or head. There's probably something like this. No, not in traversal. Is there not a lens for? It would not be an unsound. I'm not that desperate, I think. Would it be in fault? I'd be surprised. No, that doesn't make sense. Yeah, this is where I hit my limits, the limits of my knowledge of lenses. Let's see if Google has a thing. I am looking for a lens from a list of A to an A. There isn't one, okay. But maybe with type aliases, this would be. What's the definition of lenses again? It's from A to F, B to list of A to list of F. There's a traverse. That's a traverse I'm saying. No, because it's FB. But I see nothing in lenses. Okay, well. I see nothing in lenses. Maybe that would be in the getters or prisms, maybe? It's a prism, actually. Maybe what I want is a prism. Because I want the constructor for. I want the value of the. Yeah. No, I think that's incorrect. Hmm. Okay. Maybe it's a simple getter. Maybe I'm looking at something too complicated for no reason. No. Index is what I was looking at. Maybe there's an alias for just head or something? Nope. Ah, this is frustrating. Okay. Head one, yeah, I don't know if it's a thing that exists. Let me see. Is there a way to search within the contents of a? Ah, you may be right. There we go. In combinators, okay. A lens focusing on the first element of a traversable one container. Oh, but this is a. So yeah, I want head, not head one, I think. Oh, maybe. No, actually, you may be right. No, that's exactly what I want. Yeah, you're correct. And it seems to not be a lens to maybe A, so that's exactly what I want. Thank you so much. So instead of those index 0, I want, and it doesn't carry a monoid constraint. Oops. Perfect. Let's actually just try it quickly. Oh, head 1. Could not deduce traversable 1 of list. Okay. That's interesting. Why doesn't... Oh, because yes, of course, this is only for a non-empty container. That's why it's the... That's why it is valid. It does it like it's not partial. It's because it's only for things that are non-empty. Which here I want it to be empty. I'm just okay with this thing being partial. But that means I probably want to look into those combinators. There's probably something like just named head here in this file. There is indeed. Well, that's foldable one. Okay, that's different. So there is something there. Let's see. Would this underscore head be the thing I want? No, because it requires the monoid instance. Okay. Because if I do this, it gives me unit. Yeah. Okay. So I will want to do it this way, so I get a maybe of the thing. I don't have the monoid constraint. So instead of head 1, this becomes head. Ah, but this becomes... So it gives me a maybe thing. So it becomes a traverse here. Let's comment all of this out and see if I can make one of them work. The question will be, how do I make then... How do I collapse it back into a... Would it be something like just using a prism there? That might be just what it is. Okay, let's try this. Oof. Oh, wow, this is where it breaks first. We have a lot of things to fix. Okay. So why are you? Because I'm going pure in something that is a pattern. I can't do that. Those things are they are non-empty lists. So I will need to have, I don't have it here, that's fine. Oh, I have it here, perfect. So I will need to use not pure. Actually, is there a pattern? I think I have one in my prelude for a, yep, there we go. So I can replace pure with lone. That's probably because dollar is still wrong here. This should be therefore this. Ah, all the colors. Okay, the colors match. That should be good now. Is that okay now? Oh, yes, this lone thing is actually for sequences, not for non-empty lists. Okay, so no, I can't do that. That means I have to replace lone with its equivalent, which is this, like this. And I might need to import that operator, which I think is not in scope. It might be, we'll see. Okay. It is identifier not found. That comes from, sadly, tokens. I have not moved identifiers to their own modules yet. Okay. So here, couldn't match. Because module analysis, module context, this lens will be one that gives me a list of things. Wait, this head is in the end nothing different from the index 0, isn't it? So maybe I should try again the index 0. Yeah, lenses are not my strong suit. What do you mean? Hash map path non-empty role. Where does this hash map path non-empty role comes from? Because this lens is a lens from analyst state to, oh yeah, of course, this is a scope. Yes, of course. So this is a lens to analysis context, a list, and it is expecting the hashmap path on empty row, which is the scope. Okay, so I get this lens, I compose it with index 0, which gives me an analysis context where it's expecting. Okay, so wait, so can I just then. Aha, it's saying a maybe scope. So if I do that. Huh. So the index 0 in this context. Oh, because I'm composing the lens. That's still weird. I'm still surprised this index 0 actually is partial. That is very weird to me. I mean, it seems to be compiling, so it's better than nothing. But I'm still weirded out by the fact that it seems to be working like this. So wait, I can just then uncomment all of this, remove the traverse because I don't have a maybe for some reason. And or is it because since there is some type inference going on, it realizes I don't want a maybe and gives me the partial version? I don't know. This is peculiar. I am not sure I understand how this index thing works, given. Wait, actually, did I just misread it? That's also absolutely a possibility. Yeah, it's traversal from something to the x value, and the x value for a list is the A. Yeah. But that means it requires a monoid instance, right? I'm confused by this. This is now module any Yeah, I think context a lot. I'm gonna need to replace with module. Those. Okay. There we go. Nice. Now it's no longer working because it requires some kind of functor to put the thing in. So if this were instead a maybe scope, I think this would work, right? Or maybe it would need a traverse. Nope. It's still. This is the limit of my knowledge of lenses. Oh, we did this. No, this doesn't make sense. No, this would be traverse context scope, right? Hmm. So no, it's not. So it's expecting something from maybe scope. So I need to move this to a maybe lens. And traverse is not the right approach. And why is it not the right approach? What does it do wrong? Because it is scope to maybe scope, okay. Oh, in the first argument for traverse, yes, of course. Of course, yes, I see. Wait, but so what's the error there? I am extremely confused by this then. Is it that this lens requires only a functor and this one requires an applicative? Is that it? I am confused. Okay, so if I do instead have and I want to do make lenses for A. I don't know if I can do that. Yeah, I can't make lenses within. I can't make lenses within GHCI. Not with template Haskell within GHCI, which means I would need to make A manually, and A for a lens would be, or foo rather, or foo lens, whatever, is given some F and an A will be F mapping the A constructor on the use on foo. Type of foo lens will be, yep, perfect. And now if I have a list with an A0 and I am doing this to get the thing at index 0, it doesn't have the monoid instance. Okay. But if I do foo lens afterwards, why does it require monoid int then? Oh, because it requires monoid on this result. Yes, okay, that makes sense. And if I do that, okay, so I can combine the things. But what will be the type of this? It is for some kind of applicative. So is that... So I'm saying this is a lens. This might not be the right type alias for this. Because X is instead an indexed traversal, which is not the same... Sorry, a traversal, which is not the same thing Wait, what's the difference between a traversal and a lens? If I say this is a traversal, are you happy now? Nope, still. Wait, that's the issue. I'm still not convinced this is gonna work because this being a traversal, I'm still not convinced this is gonna work. If I go back to control lens setter, which is what I want, or actually getter. Let's have a look at getter. I want to look at the ones that get from a state monad. It needs to be a getting. This is one as reader. I want the monad state, which is used. There we go. It is a getting. Is this compatible with a traversal? So, what would be the type of use of this lens? And there we go. It requires the monoid instance, which is exactly the problem I'm gonna have here, because it will be used in the context where it needs the monoid instance. And I don't want that. I don't want that. So what I want is basically to make either to find some kind of custom lens that is partial, or make my own that basically does not introduce this notion of monoid. Maybe the underscore head or something like this. Okay. No, it still requires monoid. Okay. Because none of those are partial. Okay. I mean, it makes sense for none of them to be partial. That's probably a good thing. So it is time to go have a look at control lens and sound. Nope. Okay, that's not. Yeah, I want basically a lens that doesn't exist, which is the danger lens that gives me. Maybe traversal would have something like this. No, I don't think so. So look at the combinators. As much as I like lenses for a lot of things, the second you do something a tiny bit non-trivial, you end up with problems. There's another option, actually, come to think of it. Maybe I can do something better. Rather than trying to express this thing purely as a lens, maybe as I express it as a function within my monad, and I get the maybe, that's fine, and I just do a from just basically on it. Build an index preserving getter from an arbitrary Haskell function. Could I do this within two head? Yeah, I know it's. So would therefore, with the warning on two head, would this work? Yep, that works. That is ugly as hell, but that does work. But I think, rather than using partial functions like this, and after losing enough time on this, yeah, I'm gonna, just write this differently. This is gonna be something that gives me a scope in my analysis M monad. And what I do will be a use of this, and on nothing M error ice. And that way, okay, I'm doing this in the context of a use. This gives me a maybe, that's fine, and I handle it at this level rather than trying to use a partial lens. It's not perfect, it will do. And I think being a maybe means the monoid constraint will not be there. We'll see. I might have to use something else. So, everything that comes after this. Actually, there we go. Will that work? So now we no longer have lenses in our. Yeah, nope, that doesn't work. Okay, so let's go back to getter. Because I need one that is like use, but accepts something that returns a maybe. That doesn't exist. Great. Ooh, this is frustrating. Okay. I mean, some of it is my absolute want to do this with a lens. Oh, I guess there is a solution. There is a solution, which is that I keep this. Actually, I'm gonna even name this currently. I keep. Oh wait, I did not. Maybe this works actually. I just didn't have the right type. No, it doesn't. Okay. Well, in this case, I am going to. Oh, actually, I had forgotten the do blocks here everywhere, which actually are not required. It's fine. I'm gonna delete all of those. And what I'm gonna do is introduce my own lens that will do the head basically, and that will be fine. Which means actually, yeah, I'm gonna do that. Current context will be a lens from a analysis state to an analysis context. Current context will be the traversal actually, and it will be written manually as being something that takes an f and a state, and will do a case of the module context of the state of empty air ice. And if there is indeed a current context, then the result of this nonsense will be we apply the function f to c, and that gives us the new c that we use to modify the state so that module context is C prime at the beginning of CS. That's our custom lens, and now all of those can be rewritten as current context. There we go. And that should be fine. Okay, and now we have other errors. Is it because I have the wrong, no, it's fine, name, because I have said scope everywhere, which is wrong. This is a name, this is a location, this is a maybe path info resolved, and this is a hash map identifier path info resolved, and this is a boolean. Okay. No instance for monoid name? So maybe it's not supposed to be a traversal, it's supposed to be a lens. And there we go. Now this works. Which is a bit ugly. We're basically doing a manual lens on the thing. Which I guess I could do slightly differently. I could rewrite this as being... I could simplify this. Because this is module context dot unsafe unsafe head, where the unsafe head of f is that. There we go. Just probably a bit cleaner. There we go. Okay. Interesting. Oh, yes, I know why. Okay. Current name shadows the existing binding. Ah, yes. Name is fine. Which means I need to change it here. Okay, and now we're out of the lens nonsense, and we're back to doing actual useful things. This requires location. And now this is where we're going to have to modify everything. Context instances no longer exist. This is module instances. Context symbol no longer exists. This is module symbols. With local state is now called with context. Context symbols is module symbols. Analyze function is not there. That's because instantiation would need to depend on... Okay, so that's... Ooh, that's ugly. Okay. Because we're gonna need to put more things in here. We're gonna need to put analyze function there, which takes a function info passed and returns an analysis of the function info resolved. And it also takes now a list Actually, it probably doesn't. It's gonna take that. We'll get to it. We'll get to it. This doesn't take that anymore because this will be part of the context, which will be set for the functions that require it. And then that's okay. That's a lot easier. Perfect. So we can go back to here. Instantiate generic function that gives me scope info. I forgot the name. Scope name info. Yep, that's correct. Aha. Yes, those are path info parsed, not roles. And I have the exact same problem here, where I've said in my context, in my state, that here this is a list of role, this is not, those are path info past, to be set as the argument to the thing. Extremely eloquent, the thing. Okay, so lookup full name is no longer something that makes sense. Wait. So this does... Expected symbol cache maybe... Why does it expect a maybe? Is this because the on nothing M doesn't have the right... What's the default... What's the default precedence for a function used as an operator? Haskell infix function application precedence. Okay, that's what I'm looking for. It is left associative. Okay. And left associative is, I think, what we want, right? We want... Oh, yeah, of course. I'm wrong. On nothing, M doesn't work like this. It takes something that gives a value no matter what. So I would need it to be right associative for this to be possible, which is perfectly doable. Oh no. Okay. It is perfectly doable. I can just say infix R7 on nothing M and on nothing. Is that not the right syntax? Oh, because I need to put it behind quotes. There we go. It's in quotes. And now it's right associative. And this is missing the parameters. Couldn't match extended name with actual type list of name. Okay. Interesting. Because generate full name, given some original name and some type parameters, is a name, not a list of name, where I get this, and then I give a list of name. Oh, this needs to be a pure. Okay. Where they can close. What is this? Couldn't match with maybe 0, 2. Oh yeah, the with context makes this... Yeah, the with context makes this a... so I was right to have this originally. On nothing M here. Abort. Okay. And now this is right associative. This is a thing that gives me a value. And it is used as an on nothing for this thing. Yeah, okay, that should be fine now. And abort not in scope. I will need diagnostics. This looks horrible with such a... Is it diagnostic singular? It is. Oh, wait. Is it saying the opposite? I don't understand now. Let's put type to run analysis. This is supposed to be, if everything is fine, it's supposed to be an analysis M of a maybe of a symbol. Is that not correct? Yes, of course, analyze function no longer takes the arguments, the parameters. Because with context does give me a maybe, right? Scope, name, location, and it gives me a maybe. So scope, name, location of this thing, analyze function. So that gives me a maybe. Oh, of course. This gives me a maybe value inside the monad. So I need to double fmap. I need to fmap into the monad and into the maybe. Okay. Next, we have couldn't match role with non-empty identifier. Oh, no, that's this is because I'm using original. Well, this is not because of that, but this is a problem. I'm using the original name here, and then I'm making a list for each thing. The type params, I'm unpacking them, and I'm doing a case name of. And both built-in type and top-level declaration have a name. Oh, is it because I have changed those to path info past? Maybe it is. Yes, that's exactly what it is. That's exactly what it is. I find, so I have the types here, but those types, the types are names. Oh, is it, does that mean then? No. Ah, I see. On the top level, I have, no, wait, I always have, Because here I find a name that I know doesn't have type arguments because types don't use the type arguments of names, which means I want to generate the corresponding name based on this. But to do so, what that means is I need to generate a name for all of their arguments, which is the path params. That's correct, I think. So I don't understand what's wrong. Okay, so in this pattern match, in the pattern built-in type n, okay? Actual role. Oh, is it because I've said parsed somewhere instead of resolved? Yes, that's exactly what it is. Those are not... They are resolved. There we go. I was confused. Yes, and here they are correct. Okay, there we go. And here, I probably have the same error in the monad where I probably have them as instances parsed. That's incorrect. Those are resolved. I know what types they are. They are not just the name of a type. Okay, progress at last. And I suspect this. I would need a path info to be something that's hashable, to be in a hash set. I don't really need this to be in a hash set. Actually, no, I do want to disambiguate them because I want to be able to deduplicate if 3 different functions register I want foo of int to be instantiated. I don't want every single one of them to be... But names are hashable, right? Yeah. Okay. So instead I could make it a hash map for a given name of a list of parameters to be instantiated with. Let's do that. This is now a hash map from name to a list. Well, that's still the same problem. That's still the same problem where I would like to deduplicate those. But the problem is if I want to deduplicate them, it means I need to be able to compare path info resolved for equality. Which is not the end of the world, I suppose. Let's go to path info. I've been very, very cagey about... Like, I don't want equality instances on those types. I don't want equality on those types because I'm going to use it wrong. And there's so many situations where equality is more complicated than just basic equality there. But maybe I can make them hashable without making them comparable for equality. by doing something like this, where is it hash with salt, the default one? Yes, hash with salt is the default one. Okay. Now the question will be, is a name type hashable? That would be a role. Probably not. Okay, I think I'm okay with doing this thing of like, I don't make equality comparisons for things that are too risky to make equality, but I make a custom instance of hashable so that I can put them in hash maps even though I can't compare them for equality. So that means lists are hashable if the elements are hashable. Path info resolved contains path info resolved. This is fine. So now the only thing left to do for this to work is for name type of a resolved, which is role, to be hashable. Which will be not trivial. Actually, what does the yeah, the default doesn't actually require equality. Oh, so yeah, I don't have to actually write it myself. There we go. There might be a few other types that I'm gonna need to do that for, but I can therefore just do generic. Oh no, wait, it does require equality. Ah, it's part of the class. Okay. It's part of the class, which means it makes no sense for something to be hashable if it doesn't have equality. Well, there goes that idea. Okay, let me think. What I want to do is I want to deduplicate a list of types so that I don't do the same operations on the same list of types. I want to use, therefore, some kind of hash set or some kind of hash map, but that requires them to be comparable for equality, which is something I was trying to avoid. I think the second I want to do deduplication, I have no choice. I have to have equality, which is annoying because I was really trying to avoid having equality defined on those things. because it is gonna be in a lot of contexts it will be wrong to use equality for them. In the entirety of the analysis, trying to say type A equals type B would be wrong. I want to say that are they compatible? Is this a template placeholder? Is it a template parameter with an int? That's compatible. And if I make the mistake of using equals there, I will get something that is wrong, which is why I didn't want equality to exist in the first place. But if I want to deduplicate types, then I have no choice. I need to have equality. Okay. This is annoying. Could I, instead of doing this, only make it for the resolved case, which is the only one I actually want to do equality comparison on? Can I say instead deriving instance EQ for resolved only? Would that work? That means I need EQ for this. No instance for EQ role, but I've just said EQ here. And a role is hashable. What on earth? That's because I have... Okay. That's because, of course, I have some circular dependencies. I have name here, and I have a name boot. So I will need to fix that, I think. Okay. That makes sense. Instance show role instance EQ role, and I don't need the generic, I think. That is an implementation detail. Okay, so function type will also require that. Excuse me. So I'm going to do the same thing. I'm going to need deriving instance of EQ for function type and only resolved, I think. And I'm going to need, as a result, an instance of hashable for function type resolved. And this is going to require to it for identifier, which is already fine, path info, which is fine, and function archetype, which is there. So we just need to add that basically, and we should be good. And now we should be able to add stuff to the set because now it should be hashable. I forgot generic. Okay. Import isn't used. I like those errors. It means we're getting somewhere. Okay. Okay. Unused imports, those are the kinds of errors I really like. Control extra isn't used. Why do I have some? Oh, because I have. There we go. List extra, non-empty. Okay. Okay. Now we get actual errors. No, not even. Oh, this shadows. Okay, of course. Run instant. Do analysis. Okay, I have a confusion between state and context. That was bound to happen. Okay. That's the downside of having. That's the downside of having the things as monadic operations rather than lenses, is that I can't combine them with like uses to apply functions on them. I'm forced to fmap. Maybe just to make things easier, I'm gonna change that back. So all of those current things current thing become a lens from analysis state. To whatever they are. And they become just that. With some spaces for readability. There you go. So now they're back to being lenses, which means if I go back here, uses context scope becomes uses current scope. Uses context cache that no longer exists. This is oh, this is wrong. Ooh, this is very tricky. I need to be very careful here. This on nothing would be the result of a lookup in the cache, but I don't want to abort when the cache doesn't contain the value. I want to abort when the cache contains nothing, which is very different. which means I want to how do I want to do this? Because I basically want to do an F map within the monad, a F map within the maybe, and then do a basically on nothing kind of. It might be best to actually write it explicitly just because the two layers of maybe will be confusing otherwise. What I want to do is, if I have nothing, return nothing, that is perfectly fine. If I have just of something, I want to return pure just of that something, and that's fine. And if I have not that, so if I have just nothing, that is an error case. That means we did find something in the cache, but the value we found was nothing. That is an abort. There we go. Okay, and this is no longer context cache. This is module definitions. Uses current scope. Context current is no longer use current name. This is no longer a context cache, this is a module definitions. Context cache is module definitions. Analyze function doesn't require this is fine. Because I no longer need to put the mappings into here. Current fun type is the correct lens, and we've said it's a maybe, so it's just the resolved type, which means I need to look for the other context fun type here. Oops, I need to do that. And this is current fun type. I guess I don't even need to do that. Because I'm doing this maybe unit type. I could just compare them. By doing a lift A2 of type matches on the two things and doing a from maybe false. This is fine. Context scope, current scope. From maybe. Current location. Current location. currently within loop. Current scope. I could have done a mass rename, but there was a risk I would have gotten it wrong. This is another case of me doing bracket stuff on the context. Can I just do that with the entire context rather than doing it with the scope and everything? Because when I leave the scope of a loop, all of the scope that is changed is lost. With this new context, which is specifically for functions and stuff, yeah, I might just do it as a bracket, as a context bracket. So how do I do that? It's going to be very similar to this, but this is going to be using the current context. So assuming there's one, so nested context with nested context. There we go. The only thing is, the only thing is, this one modifies stuff in the scope. So this one already makes changes. But basically, every different loop will want to make different changes. So how do I bracket that? Basically, is the correct is the question. I guess I could nest the context, but that's adding a bunch of unnecessary. That's adding a bunch of unnecessary new contexts. Another option would be to give to analyze block the context. Because this is exactly the kind of stuff I want to push a new context and then pop it when I'm done with the loop. That's literally what I want to do. To avoid doing that kind of stuff where I'm modifying the state everywhere. The upside of doing the with the nested context thing is this simplifies a lot of the code there. The downside is I'm gonna be duplicated context for no reason, which performance wise is not great and might be confusing if I try to introspect the data. It also means that whenever I end up going through. There is another option. That might be the better option, which is rather than having the nested thing take a callback, I make analyze block take a callback of how to initialize the context after doing a push. Then that way I only push one context per thing. Yes, I think that's the correct approach. Let's do that. So with nested context will be a function that given some analysis, some action in the monad, will return another action in the monad, but will bracket it with nesting the current context. Okay. So we get the current context. We modify module context is gonna be modified by pushing a copy of the current context at the beginning. So we're pushing a copy of the current one to get a nested context. We get the result of the action, which has therefore to be a try of the action. We drop. Actually, I could just copy the thing I was doing here. Basically, this is exactly that. But the context is not this context, it's with a nested context. So it's that, basically. What was this thing that was? Yeah, okay. Okay. But the difference is context is use current context. Okay. So now this does basically what I wanted, and I can rewrite analyze block as something that takes some kind of action in the monad to set up, to initialize context, set context. And what this does is rather than manually doing this previous scope, context, scope, and so on, does a with nested context do I don't even need to do the context scope anymore. I don't need to do that anymore. It's perfect. This is just run set context, whatever that is, and do traverse analyze statement of the statements. This gives me a maybe of the thing, and I am happy in this case to simply do a fold. And there we go. No need to do this kind of restoring and modifying the state. I stack a new context on top with its current scope and everything. Now that means that every call to analyze block will need to have some initialization of the context. Here, there's nothing to do, so that's nothing. However, in the other places where we use it, like here, the action we do is to initialize, to change the new nested context with this context within loop is true. And now we no longer have to surround all of this with the like get the previous value, set it back. We are using nesting properly now. So that's the same thing here. This is. Oh, now I need. Oh, that's interesting. Okay, now I need to do more. So let's actually name it. This is set loop context. Update init loop context. And it is just that. Init loop context. Here we have kind of the same thing. Within loop is true, but also the scope is being modified to insert the name of the for variable name. And here I was no longer doing, here I can go back to doing an analyze block because I am back to being able to do perfect. Perfect. So now I've bracketed a bunch of operations around blocks, and I've removed the need to do a bunch of get the old value, do the thing, reset the old value, because we're nesting contexts properly now. Yes, this is supposed to be a maybe a. Okay. More lenses that are true. This is indeed currently within loop, not context within loop, and this is current scope. And indeed, the previous one will also be currently within. Context scope doesn't exist. Current scope. Because this is not, this is a for body. Copy pasted the wrong thing. Okay. Aha, this also has an analyze block. I don't need, I'm not doing anything around this. So a pure nothing is fine. Is there actually a alias for this, or do I want to create it? For something which, for some applicative M, is an M of unit. There's pass here. There's obvious. There's unit here. I don't like any of those names. Pass is not the worst, actually. Yeah, pass is not too bad. But it's not in any of the libraries I depend on, so time to go to my prelude. Do I have any monadic thing in this? I don't seem to. Interesting. Technically, yes, only needed on applicative, but okay. And now here, I can just do a quick replace of. I don't think I want to every single one to use pass for, but when I have to give it as an argument to something, that's a pretty convenient argument to give. There we go. Defined but not used. That means I'm not exporting it. That's a mistake. And this is pass. The prelude changing means everything is going to recompile. Okay. Ah, it was too good to be true. What is this error? I suppose here I need to pass as well. Aha. Aha. So here's this function type matches is the reason why I didn't want to have equality on path info and why I'm annoyed I have equality on path info to have it hashable, because a lot of the time are those type equivalent, do they match, is not as simple as are they equal. For instance, if we end up having void, yeah, it type checks everything. However, now that I have changed the fact that names, that built-in types actually contain names, I am going to have to change this. So let's go back to name, actually to built-in. And I will introduce instead do I want to make that a pattern? Yeah, after all, why not? Since I'm already doing it for all of the things, int name, which is name, int name is that nonsense. Okay. Although I don't know if placeholder actually requires. No, it doesn't require a name. Placeholder is different. Okay. So with int, we have character, we have boolean, we have unit, and we have void. Okay. And now I just need to replace those. Okay. And now here, instead, I can use their names. So that would be character name. That is a boolean name. Unit name and void name. And that means that back here, this is a pattern, and I can say void name. Okay. Don't think we're compiling just yet. But we're getting close, I think. Oh no, core seems to compile. Nice. Okay, we're getting very close. Okay, so here context cache no longer exists. This is module definitions. And in fact, here we want to export the symbols and the functions. And we already have that. So instead I can do a get. I can do a get of the analysis state. And the resolved module will be initialized with exported for this. For the definition, it will be the module definitions. Well, it will be cat maybes of them, but nonetheless. And for the symbols, it will be the module symbols. And for the functions, it will be the module functions. And this up, there we go. Is it not the name? I suppose I don't keep the functions in there. Because I don't need to, I suppose. Because it is enough to just... It is enough to just go over the definitions again. And for everyone that happens to have... but if I do so, I'm going to have to recreate the names and everything. I might want to just do it as I go. It might be a lot easier. So that means module functions. Which is the function cache, which is initialized as empty. Okay. And now we've changed absolutely everything. Unuse the imports. We love to see this. And now it compiles. Okay. We're not done yet. But having all of those changes we've made to the context and the way the context work, compile is already a pretty big step. Now we need to start doing the actual instantiation. So, oh god, there's so many things to do. There's so many things to do. Here in the instantiation, I will want to do... I have the parameters, and what that means is when I do... I'm going to rewrite this. Because this is going to be a with context. I'm going to create a context for the analysis of this function, as is always the case. However, in this one, I'm actually going to say that the current params are the parameter that were given here. I am setting those. Actually, this is a list. I'm going to need them to be a hash map. So maybe something... I'll have to see whether I want to make the translation into a hash map at the call site or here. Likewise with the try instantiate. Do I already have a hash map from... do I already have a hash map from name of the template parameter to the thing? If yes, that's a lot easier. I'll take that as an argument. But it will at some point be set the current parameters to that, then analyze the function. which gives me the result. And which is the resolved function, I suppose. Let's be more explicit. And my result is a symbol, which is a function wrapping the resolved function. There we go. And now this crucial line here is what makes all of the difference. Okay, so that's one thing. Now the second thing will be in context. I am going to need to make something, which is when I do a resolve type, I will resolve path of the mode, which will then call this callback, where I have the path info. And here I'm gonna want to actually, it's probably gonna be in resolve type with that I want to do that. Resolve type with, there you are. Ensure process callback. There we go. Aha, maybe actually this is gonna be not even then. This is gonna be in resolve name, possibly even. Oh, I don't, I cannot support higher order, higher kinded type parameters, which I think is fine. Like a type, a parameter to a function needs be a type, which means if anyone actually specifies, okay, this function takes some parameter of type t and then tries to do t of int or something like this will not work. We do not support higher kinded template parameters. Could I support them? I don't think so. Not in the current, not with the current stack. Okay, because what I want to do here is, here's this resolve path. When I'm done, when I have a role, I need to check, is this a type parameter? And if it is, rather than using the this path info, I need to substitute the path info that I know is the correct type from the the params that I know of my instantiation. Trying to do higher order things here would mean that I am pointing not necessarily like to a partially resolved path info. That would be a nightmare. It's probably doable, but I don't think I want to do that for anywhere in the first version of this. Okay. So I think it means here, if there are parameters while I have a type, then that's wrong and I can just ignore them, basically. I can just, it's an error. Okay, so that means here I have to do a case rule of, and if it is a type parameter, t, then what I do is I try to see if I can find it in the instantiation parameters of my context, which means I am doing a uses current params, and I'm doing a lookup of t. If this succeeds, it gives me an actual path info. Which means I just want to handle but I want to do two different things depending on whether it succeeds or not. Okay. If it gives me nothing, that's perfectly fine. That means we are in the context of a generic function. I have no problem just saying this, basically, which will also be the case for any other kind of role found here. To the point where I could probably introduce an alias for it. There we go. However, in the case where I do find one, then this is where I need to do some additional check. Unless null params I'm gonna want to do a fatal error. It doesn't make sense. So this error is going to be something that we don't have yet. And then pure that particular path we have found. Okay. Diagnostic. That's kind of because we do the type resolution in an ugly way. If I could instead substitute so that the name points to if I could say that the name points to some kind of type alias, like introduce a fake type alias in the scope, basically, then I could support higher kinded type parameters out of the box. Oops. But for now, we cannot. So error type parameters to type parameter. Okay. So now that's it. We have now our functions that have type parameters will substitute the right thing for them when trying to resolve a path. Which means we will get actual proper functions instantiated. Okay. What are we missing? We are missing actually instantiating the functions, which will be done here actually. Because I do have... Or do I want to not do it actually here? I know I have an instantiation comment here. There we go. That's the partially resolved function type. When is that called? It's only called in the context a few times. Oh, it's all called within this file. Okay. Yeah, that makes sense. That makes sense because they can appear in expression values. So I think this might actually be the correct place to do that, not for function calls only. Since now we kind of support function pointers, that means if I create a pointer reference to foo of int, I therefore need to instantiate it. So I think this is correct. This is where we need to try or register the function for instantiation. Oh, that is wrong. That is extremely wrong. I thought I had fixed this already. Oh no, I already checked that the number is the same. I can't give a partial number of arguments. Either none of them is given or all of them are given. So no, the zip is fine. Okay. So I do have a mapping. Perfect. I don't have to create it myself. That's good. And that means here I should be able to do try instantiate function for a generic function. If it's not a foreign function, it will register it for to be it will register it to be instantiated at the end of the processing of the module. So try instantiate generic function. There we go. Needs the name and the mapping. So that's perfect. I don't have to do any transformation there. I can just immediately say with context current params, perfect. And now here I only need the name of the function and the mapping. And that is enough to try to instantiate it and otherwise register it to be instantiated later. Okay. Okay. Now, what are we missing? We're missing the instantiation of local functions at the end. We need to do that. I also need to start writing some symbols. And that is all going to be in core. It's the reason why earlier I've introduced do blocks for the analysis of enums and of constants and functions, because here I have the resolved info. I am going to need to register this as a symbol to be exported from this module, to be part of the object file of this module. So module symbols will be modified to insert the root name and the symbol constant with the resolved info. I will need symbols qualified as S for I have two things named S. This is fine, probably. Nah, this is it's probably fine, but I don't like it. So I'm programming it as symbols. There we go. Which means constant. Here, this is symbols constant. There we go. We are gonna do the same thing for the functions. Well, do we? No. If is constant is generic resolve the info. Then add it to the cache of generic functions that need to be available for the rest of the compilation, which is the module functions cache. And it needs the parsed definition, interestingly. So it needs the info, and it needs the top level scope to go with it. Otherwise, if it's not generic, then it can be added to the module symbols. The problem is that this is generic doesn't work on a function info, so I'm gonna need to it doesn't work on a because this is generic is on a function type. Oh, actually, I should do this is wrong. Here in context, I'm doing try instantiate for a generic function. I need to only do that if it can be instantiated, meaning it is generic and it has only known types. So I need to do a can instantiate. And in fact, I can do it on a function info for any type P, it doesn't matter. Because I am only looking at the function info. I am only looking at the parameters, which does not depend on the phase. What parameters is it? Yes. Okay, so that works on any function info. That's perfect. So now this is fine. So the is generic in the core will work, and the one here I just need to do when can instantiate, and this requires the function info and the mapping. When that's true, try instantiate for a generic function. Perfect. Maybe this one should be part of this one, so that there's only one function to call from the outside, rather than having to make this check every time, and this one is broken if the check doesn't pass here. That feels like a bad that feels like a bad way to use it. So I think this try instantiate should incorporate the can instantiate actually. Okay. So this becomes when can be instantiated, do all that, and can be instantiated becomes a thing here, and it becomes this. That's interesting. Because I need the function info, which I would get from this in the first place. Like, I try to get it. But the one I would get would be, yeah. Yeah, this feels a tiny bit ugly, but this is, I think, the right approach nonetheless. Okay. So I will need the function info, which is not necessarily the definition that is here. So they might not be the same type. And in fact, if the function can be instantiated, they will not. So that's a bit of duplication. But I need to know because in the context where I don't have the info here, I still need to know if this thing can be instantiated. Yeah, okay. So base info, is that generic? And are all of the... Is all actually working on any foldable? It is, okay. And hash maps are foldable, so that should be fine. Right? Yes, they are. Perfect. So all will work. Which I think I can just rewrite this as this. And now all is concrete. Path info. Yep. Okay. So there are type parameters to the function, and the mappings I have provided, all of them are known built-in types or top-level declarations that I can trace back to, which means I know all of the types. I can instantiate the function. Okay. Which means I can go back to context. I can remove this when. Try instantiate needs the function info as well, which is the info. And now this is fine. Okay. With that, what am I missing? We are registering non-generic functions as being a symbol of the module to be like exploited as part of the symbols. We are putting generic functions into a cache so that other modules can access their definitions and reanalyze them when they are being instantiated. Whenever we encounter a function type, whenever do we actually resolve function type? Yeah, basically, whenever we encounter a function in a context where it makes sense when doing the analysis of the code of a function, then After doing the analysis of the parameters, after doing the analysis of the types within all of that, we try to see, hey, is this a generic function for which we now know all the parameters? Try to instantiate it if it's one that can already be instantiated immediately because it comes from another module. Otherwise, put it in the queue of things to do at the end, which is one of the last things we haven't done. However, one thing I need to do, which I think I've done but I want to check, is, yes, okay, when we do instantiate a generic function, we do put it in the symbols of the module. So that's good, perfect. So now the last thing to do is to go back to the analysis, the top level, and now, after we traverse all the definitions with analyzed definition, we are done analyzing the definitions of this module. It is time to it is time to process the queue of functions that we need to instantiate that are coming from this module that we haven't. The thing I was stuck on for a second was, if a function within the module makes a reference to itself, is a generic function that is recursive, I try to instantiate it. So it is in my set of functions that need to be instantiated. But it will, in the process, register itself as a function to instantiate. So if I'm not careful in the way I do my loop, I might have, oh no, it should be fine, because even if it re-registers itself, when I go back to my main loop and I continue processing the set, the next time I encounter it, I will be saying, oh, it's already in the cache, there's nothing to do. So I don't think there's a risk of infinite recursive instantiation. Okay. So here now, after analyzing the definitions, we need to process the queued instantiations, which are the module instances, which I'm tempted to make as a new function just because this is going to be I could actually make it in the instantiation module. I will probably want to use one of the monad loops. So I will probably want to do a loop of while the set of things is empty, pop one, give it to me, and modify the set as such, run the thing, and do that again, basically. I probably want some kind of while just or something like this. Yeah, while just is probably what I want. I modify the state to pop one element out of the set. So now my state contains one fewer thing in the set of functions to instantiate. I run my operation with that thing, which is simply going to be instantiate the thing, which might modify the state again, but the action is run every time, so that's fine. And again, since whenever we encounter a function that has already been instantiated, we don't reparse it, it's fine. So I think a while just is exactly what we want. And the question is, can I do like there's definitely a pop or something function on hash sets that gives me some value from it, and maybe not on hash sets actually. Maybe not on hash sets. Maybe I need a regular set for this. Although I guess I could do something absolutely horrible, which is to do a minimum on it, but nah, that's not great. Yeah, I think I want not a hash set, but something else. Because I want to be able to maintain. Let's have a look at the regular set. It requires ORD instead of EQ, which is going to be annoying. Yeah, there is something like take, where I can just take some elements from the because they are sorted in the set in this set, which I think is implemented as some kind of finger tree probably. Yeah, this min view max view is exactly what I want. So I should switch to a set, which is going to break everything. Okay, let's do that. So this is no longer a hash set. Which I think isn't even in my prelude. I never use the non-hash version of those containers. Yeah, it's not there. This is now a regular set. That means I need to go back to name. I don't need hashable anymore, but I will need ord. I can leave hashable at this point since I have EQ anyway. Might as well keep it. Now I need to go back to here, and every place I've put this, I need to add ord for the set. It also means that in the instantiation file, here when I'm doing, this is no longer a hash set, this is likewise, oh, I have the same thing here. I need to fix that symbol. This is a regular set. Okay. Wait, is it the same thing, qualified as symbol and just qualified? Or qualified, would qualified mean the full thing? I don't remember. Okay, I thought, oh yes, of course. I need to go back to the boot file for name, which says now that there is an ord instance for this. Now we need to recompile the AST, which means we need to recompile the parser, and everything has to be recompiled. No, so qualified would be the full thing. So I think qualified as symbol would in fact work. Yeah, okay. Aha. Yes, this is no longer, since now I have the mapping directly, that means that this thing here is also the mapping. So that's a hash map of identifier to path info resolved. Okay. Aha. Oh, that is annoying. For the purpose of generating the full name, I need them as a list, sorted in the order, so I don't have to do the mapping, but I have to reverse it now. Okay, so I'm gonna need the sorted parameters. And what this is going to be, I do have the definition. So this is gonna be for each parameter name in the function parameters of the located definition. Pure yeah, here I can make here I will make some assertions that like yeah, this place thing is called in one place. I know the mapping is correct. I can just do a partial thing. I think it's fine. This becomes a params. It's a lookup of the parameter name in the params so that those are sorted in order. And on nothing, that's an internal compiler error. No recovery here. And then we can create the full name with the sorted params. Okay. Couldn't match kind star with AST phase. Fascinating. What are you on about? So params is a hash map from identifier to path info. The fun params of the located definition. This do block is a list to block. So this is a list. Sort params is a list. Okay. Oh, because on nothing is something that is monadic. It expects to be outputting something. So what I want to do is this actually. There we go. Type constructor type parameter should have 2 arguments. Does it? Oh yes, of course it has a module name now. Okay, we're back to core. This expects a with location function info passed, which is Hello. So it's not the info, because the info, where does the info come from? Oh, it's this thing. No, okay. I need to, I guess I can just do that. Because with location is a functor. It is. Okay. And let me just check that I remember which one is which. Yes, that's correct. So, info in the definition. That should be fine. And there we go. This compiles. The only thing missing, we fixed everything except yes, the last thing that is missing is now doing the instantiation of functions, of generic functions that appear qualified within the current module, which needs to be done at the end. So we go back here. We analyze every single definition within the current module, which will have triggered the instantiation of foreign functions that can be done inline, so that the errors happen at the same time. However, for local functions, I need to wait until they're all defined to avoid cycles in definitions. I think. Yeah, I do. So here, now that I've done that, I can do a while just, and this while just will be a set. Oh, I have hash sets in this? I do. So I'm going to set qualified as set to be very explicit. So this is going to be the set function that we had identified, which is the wait, those are partial. Yeah, calls error. Yeah, okay. It's min view that I want. So that's min view. And specifically, this is on the state, so a monadic operation. I'm using the module instances, and I'm getting min view. What this gives me is in the case where it is something, not nothing, and therefore this callback is called, it gives me a tuple of one element of the set, which again is a tuple name and parameters. So that's name params. Which is the first argument, and the second thing it gives me, the second part of the tuple, because this gives me a tuple. So the first thing is itself a pair, and the second thing is the remaining one, the remaining instances. What do I do with this? So while there are more things to process, it's fine, I will update the set. So module instances is now the one without, is now the remaining ones, because I have popped this one from the thing. And it will be modified if when trying to instantiate a function, it registers more things from the local module, but that's fine. It will not trigger an infinite like list of things, because if I try to instantiate one that has already been instantiated, that's a no-op. And here, the last thing I need to do is simply instantiate generic function. I have the name, I have the identifier, I have the identifier, that's the mapping. I will need the definition that I can get from the current context. And I will need the scope, which I have trivial access to. Okay. So I need to get the function definition from the name, which is what the function cache is for. So I can do a uses module functions, and the function I apply on this cache is a lookup of the name, and on nothing of this thing, I will just panic because it means something went extremely wrong. Now I have the function definition. I need the scope in which that function was defined, which is a top level scope of the module in which it was defined, which for those is the current module, which means that is simply a top level scope is just looking into the reader. Actually, I don't even need to. I already have access to it here. It's right there. So I can call instantiate generic function with the top level scope, the function definition, and the parameters. And the name as well. I don't remember in which order those arguments are. Scope, name, info, params. Scope, name, info, params. Okay. And that should be everything. And now we're going to have to test this. When it compiles, obviously. Well, just I did not import well just. It is part of control monad extra. No, wait, it's control monad loops, isn't it? Yes, while just is control monad loops. Because there's both control monad loops and control monad extra. Both of those are very useful, and I never remember which function is in which. Because control monad extra has when just, but I want while just. Aha, but it has also a while just m. Yeah, no, it's the one from loops I want. So it's a control monad loops while just. There we go. And I need to import the instantiation module. Oh, yes, I suppose this gives me the scope. This gives me the scope. The only way this can be not the scope is if something went extremely wrong. So I think I'm just gonna ignore it. Because since I am instantiating foreign functions that have a different scope whenever I see them, the only way this could give me a scope that is not the local scope is if somehow trying to look up the information of a foreign function didn't work, which is a big error in the code base. I can just ignore this, I think, and just get the definition. Especially since I'm looking up in the module functions. Nah, yeah, no, absolutely, it makes no sense. Okay, this compiles, and I think that's everything, which means it's time for a test. Let's go back to I'm not going to use those files again because I want to try more interesting cases. So let's create an A file and a B file. What's the syntax for my imports again? So A will define a function A1 because I am not very original, parameterized by a parameter t, which takes an argument of type t, returns a value of type t, and returns that x. It does nothing interesting. It will have a function a2 that has x int, takes an int, that returns a1 of x, thereby forcing the instantiation of a1 of int. So now a1 of int should be in the result of this module. As part of the symbols of this module, a1 of int should be in it. Now, we'll create b.py, use a, and here I want to do the same thing, kinda. But I think I want to test a few things. So I want to make an int version that calls a1. So this should force the instantiation of a1 to be part of the symbols of b, because again, we generate all of the symbols that a thing requires for generic functions because we can't guarantee that it has been instantiated by another module. And here, b2 here will do the same thing with a character and return a1 of that character, forcing a new instantiation that was not part of the A module. Okay. There is one thing missing. I need to go to the actual main here, which is this absolutely ugly thing I'm using for testing and debugging purposes, because what I want now is here, when I'm done, I have exports, definition, symbols, and functions. And I think at the very least, I want to see all of them. So let's do I probably want to print them by module rather than print them by... Yes, the problem is if I print them for all of the compilation, I will get, since all of those hash maps use the unique name of the thing as a key, I will know that, like, oh yeah, sure, that function has been instantiated. I will not know in which module it was. So I will need to do this here instead. Okay. So Let's print the definitions. Then let's print this. Let's print everything, and let's see. So for every symbol, it's going to be name and symbol. I don't think I've made symbol. No, I've made symbol an instance of show. Perfect. Oops. Okay. So that's the list of symbols exported from this module. And finally, generic functions. Which will contain scope that I will not care about and the function and the definition, I guess. Show the definition. Okay. Let's try to see if this compiles. I've only modified the main, so it should be fast this time. It's unhappy about... I don't use any of those things. Okay. Okay, let's pass. Okay. Yes, of course. I need to lift IO all of those prints because I am not operating in... I am not operating in the IO monad, but in a monad on top of it. Okay. Is that enough? No, because I can't type. Okay. Hopefully this should be fine now. Most defined but not used. Those are errors I am okay with because they indicate warnings as errors, which means there are no longer any errors to report, which is good. We like that. Okay. There we go. So now I'm going to unzoom this a tiny bit. Oh, where is it? Is that in this? Oh, it's of course in this one. There we go. So here I'm going to call it on A and B. Actually, let's try just A on its own. Okay. No definitions, no symbols, no generic functions. This didn't work at all. Great. Is it because it didn't pass? No, because we arrived here. If there was any error before, we would have had an error. Fascinating. How did they break it so bad? Okay. Huh. Interesting. Oh, of course. I am printing the wrong thing. That explains. I am printing the ones that were from the cache before. So that explains. If I'm printing the wrong thing, yes. I'm not expecting to see good results. Okay. So, in the definitions of the module A, we have A1, and we have A2, which is to be expected. A1 is a function definition that has a parameter t. In fact, I kind of wonder if I actually need to put it there in the definitions in the cache. Actually, yes, I need it for function resolution. No, yeah, it needs to be that. Okay, which takes an argument x by value, which has actually is a name a type parameter linked to the function a1, and the name is t. It has a return type, which is a type parameter, which full path is aa1, and the name is t, and the body is a return statement of a type, which is a type parameter something something, and function argument x is the value of the value of the return is a path expression pointing to the function argument x. Okay, a2 is a function, takes an x by a value which is a built-in type whose name is int. And the body is a return statement of a typed expression which is a call expression. That is something that is wrong here. I need to make sure that when I oh, that's annoying. Oh, that's very annoying. Okay, I will need to figure out the full name of the thing, of the function, of the generic function, because, oh, I'm calling a function that is fully instantiated and it was a generic function. I need here to say that this call expression is not going to a1, it is going to a1 of int. I need to know that. And here I don't, so that the linking can work properly. A concrete function cannot afford to not point to the exact symbol. So that's a bug. We need to fix that. Okay. But otherwise, it is calling a1, which is correct, with a parameter to a1, which is a parameter which is an int, and with an argument, which is a typed expression, which is an int, which corresponds to the function argument x. Yeah. Okay. In the symbols, we have a2 within the symbols, but we don't have a1. So something didn't work there. Because we should have, in the call to a1, realized, oh, this is now a function that is concrete. We can instantiate it. We must instantiate it. And therefore, it should have appeared in the symbols here. And it didn't. It did appear in the generic functions, however, which is interesting. Okay, so something is wrong with the way we are calling for the instantiation. Let's go back to it. That is in context. So there's also another thing I want to change. I want to change context again. Wait. Am I being bitten again by the problem, the confusion between names and... Here, the call expression is pointing to... No, it's pointing to a top-level declaration. That's correct. However, it needs to be pointing to not a1, but to a1 parameterized by int. The name needs to be changed. That means that the path info that I return here, which is this resolved path, needs to be altered to reflect the correct function name so that we can link to it accordingly. However, I need to check when I do use partially resolved function type. Aha, here I ignore the path info because I am making it a function pointer. With the resolved path. So this needs to be the true path, and I need to not ignore it. Because if I have instantiated a function, I need to be able to link against the correct one. I guess I could always, at a later time, be like, oh, this points to this thing with those arguments, and reverse engineer the name, but that feels like it's a mistake. I think it should be... Yes, I think this is what it should be. So, true path, true path. Okay, and in this case, the path info is returned. Perfect. Likewise here, perfect. Now, the only thing I need to check is this is resolve function call value and resolve exp value. In the case of resolve exp value, it is wrapped in a function pointer thing, so it is fine. But for resolve function call value, I need to check that I'm not making assumptions. Resolve function call value. What do I do with the resolved path after this? Use it for the error message. And then analyze the function call arguments. I do use it for analyze function call arguments. Okay. Oh, and I seem to mostly use it for error messages. Nope. I do modify the path params. Okay. So that means I need to be very careful and treat the name and the path params as different things. Okay. That means that here, partially resolve function type, in this thing here, this might give me a new name for the function that is being pointed at, the actual symbol name. And if it does, then if it does, I need to modify the resolved path to contain that name. However, I don't know. The problem is I don't know how to modify the path info because I don't know what kind of function it is, because it could be either a built-in function or a top-level declaration. Worse, it could be a function pointer. No, it's fine. It cannot be a function pointer. No, it can, but if it's a function pointer, it has already been instantiated. Okay, let's do this step by step. Try instantiate foreign generic function will give me a maybe name, which will be the true name of the function. Shall it actually be successful? Which means I just need to extract this as a separate function. Which will take the function, which the original name, and which will take the mapping. And will return generate full function name equals go. Well, name params will be go name and which means I need the function info, I suppose. I need the function info, yeah. I guess it's enough to take a list of identifiers regardless of where it's coming from. Names, mappings, and this is go name sorted. I'll go name and do, and I'm just going to do it in line. And this do block is going to be this. Okay. And go is going to be that. And here, do I need to handle function pointers? No, those are the types. That's fine. This is not where I need to handle function pointers. Okay, so generate full function name is now done, which means here I can use generate full function name by giving it the name, the params, and I will need that, which is actually param names here. Okay, so that's the full name in the context of this function, and I guess it can return the full name. So this can no longer be a when. This become an if. Then do that. In this case, return the name, so it needs to be put into a maybe. There we go. In this case, I still need to generate the name. So generate full function name, which takes the original name. The fun params of the base info and the params. Okay. Okay, generate full function name. So that's pure just that, because that is a total function. Well, not a total function, but a non-monadic one. Okay. So now this gives me maybe the name of the function. Quickly go back to analysis, make sure, yeah, this discards the name, that's fine. I don't care about it because this is no longer a place where I need to propagate the name back. Here in context, however, is where I will need to inspect that. If it gives me a new name, this is where things get very complicated. Otherwise, that's just a resolved name. Nothing has changed. Okay. What that means now is that I need to do true name, resolve name, and path name modified with case. And here I need to see all of the possible roles to figure out which one is correct. So here, roll this, this, I'm hitting some of the limits of my design here, I think. I mean, this is gonna work. It's just, it's ugly, is the thing. So if it is a top level declaration, it becomes a top level declaration with the true name. I'm pointing to the right function. If it's a built-in function with a name, that assumes that it's a built-in function that has type arguments, but that's absolutely possible. This is now a built-in function with the true name. Type parameter makes no sense, placeholder makes no sense. Function pointer, however, and one day perhaps function arguments, but not for now. Could it be a let variable? No, I don't. Shit, it could. No, okay. It cannot be. We only ever call this in the case of... Okay, so no, I resolve it to put it in a I resolve it to put it in a let, so it cannot be a let at the point where of the resolving. Okay. Wait, is that correct? Is that correct? Yeah, I think that's correct. Which means I just need to make sure that the name is correct when pointing to it, when creating it, which is what this does. And after that, the value will be a function pointer, which is gonna be correct. Okay, no, this is fine, I think. So back here, I don't think I need to handle. Huh. I don't handle function pointers in function calls. That's a mistake, I think. Well, I guess no, that makes sense. It must be bound to something, so it must be some kind of a let variable, I suppose. Ah, yeah, there we go. Check function type, and if it is a function pointer, then yeah. Okay. Okay, so this would be fine. So let's go back to partially resolve function type. And so, yes, I believe that those are the level declaration built-in functions are the only possible ones because I create the function pointer based on this, which means here I have found a definition for the thing. I have been able to try to actually resolve that thing. It means it had a definition. It is only a top level declaration or a built-in function. Anything else is an error. And we output the true path. Okay, so that fixes the problem. That fixes the linking problem, where now calls will point to the right name. That's wrong here. That's missing an else. Else pure nothing. Okay. Okay, what's wrong here? Params doesn't exist. This is mappings. This probably will not, this is go recursively. This probably will not fix the problem of the instantiated symbols not appearing in the module, but this will fix the problem of function calls not pointing to, excuse me, to the right place. Resolved path, not name. And likewise here, resolved path. Okay. Yes, I suppose. This is not actually, yeah, it's purely a map. I don't need the monadic thing here. I'm just f-mapping a thing. Yep, there we go. Okay. So now A1 is still missing from the symbols, but now, hopefully, A2, which contains the same thing here as here, let's see. The return statement contains a typed expression of type built-in type int, and it's a call expression, and the path name, the name of the function being called, is A1 with no name parameters. Ooh, this is broken. Oh well. So what I assume then is that something in this try instantiate foreign generic function doesn't work. So maybe something here doesn't work. So let's show the base info So let's trace show the name, the base info, and the parameters. Let's see. Is it because I'm not giving actually any argument to my call to A1? I don't think that's the case, because here in context, in partially resolve function type, here, if the arguments are null, then I am creating a mapping which is parameter name to placeholder type. Oh! Fuck. At this point, I don't know the function type. And that's because I don't know yet that's because I don't have access to the type of the arguments. So here, not knowing the types, I am putting placeholder for all of them, and trying to instantiate will fail because I don't know the type of the arguments. So this is the wrong place to do the try instantiate function. Actually, it should be called try instantiate generic function, not try instantiate foreign, but So that means when I'm resolving the function, I cannot decide. I mean, I probably can, but this is nonetheless the wrong place for this. What that means is I need to move to wherever this function is called. That means here I must validate that it does not contain placeholders. Oh, this forbids placeholders. So in this context, we're good. Okay, so here, this will not be allowed if the function is not given all of the arguments. It must be given all of them. So I can probably go back here and I can probably just keep this in place, because when I'm resolving a function pointer, it will be given all of the arguments, therefore this is fine. However, what this means is this place is a correct place to try to instantiate a generic function, but it is not the only place where this needs to happen. The other place where this needs to happen, there is, we're getting a function pointer, therefore all the types must be given, and there is, we're making a function call, and we can derive the types from the arguments. So that means I need to go back to core. It's function called args. Okay, and here at this place, I have everything. I have the fully resolved path, I have the mapping, which means now I have the up-to-date mapping with the information from the arguments. I have been able to do all the type inference from the arguments. Therefore, here as well, in the case of a call, I can try to instantiate the generic function. I will need some amount of function info. That's annoying. That is extremely annoying. I don't have the function info in this case. I don't need the function info. I only need the parameters. But this is going to be the full mapping. So I'm missing. Do I have it in the fun type? I have the parameters. I do have the parameters from the function type. Okay. So here, the info, I'm going to replace that with fun type params. I'm going to need the name, which I guess is part of the resolved path, but I will still need the name. And that is enough to then fully resolved path, or otherwise fully resolved path, and modify the path name. Okay, and here I need to be careful to not use resolved path anywhere. I need to use the true path. Okay. I can remove this here because I am already doing that. So I am missing. I need to change the try instantiate generic function to only take the parameters. Excuse me. And I need resolve function call value to give me the name. Okay. Doable. So that this now takes not the function info, but a basic list of identifier. I can keep is generic here, but that's just gonna be not null. Not null params, I guess. Oops. All is concrete mappings. This is mappings. Mappings. And the info isn't used anywhere. It's this one. Okay, perfect. Base info is there, but fun params, that's the params. There we go. Okay. So this now takes the identifier. Perfect. Generate full function name as well. And this will take the function info. Okay. We're good. So now I'm going to need to change calls to try instantiate generic function. But first I need to change resolve function call value, that's the one. I need to include the name in the result. Okay, so here I'm just calling partially resolve something. Oh, I don't have the name here. I don't have the name here. Function pointer. Hmm. Could I change the role of the function pointer to also contain the name? Because to create a function pointer, I need to know the name of the function I'm pointing to. Wait, I don't. I don't. It could be. It could be an argument to a function, and therefore I have no idea what's in it. That means I might not be able to know the name. I might not be able to. Okay. Okay. That means this gives me a maybe name, which will be nothing in the case of a function pointer, which is fine. In the case of a function definition or a built-in function, then that name must be known. Partially resolve function type gives me the name always. Name, there we go. And actually, that needs to be a maybe name to be compatible with the rest. So that's just the name always. So here, try to instantiate the generic function. I will need to give the fun params instead. Okay. And I guess this is actually... Oh no, I need to give the true name. Not... Yeah. Okay. So now I'm giving the true name. Perfect. That should be almost everything. Now I can go back to core. Here that name is a maybe name, I guess. I don't like to... true name, but it's not guaranteed to be there. So what I need to do now is case of a true name of nothing. The true path is the fully resolved path. Nothing has changed. If it's just a name, then I can try to do this again. Or I guess I could just... I can probably sequence a maybe, a thing in the maybe monad. This is from maybe fully resolved path. Do get the name from the true name. If that's nothing, we immediately exit. Except I might need to sequence. Nah, it doesn't work. I don't think. Unless I do a maybe T, I might do a maybe T. Yeah, I'm gonna do a maybe T. So this is that of a run maybe T of name is hoist maybe of the true name. Wait. That's not the true name. That's only the true name if it has been successfully. Ha, no, this is just a name. God. So this is the function name. And then the true name. Let me just check which one is hoist maybe, which one is just maybe T. Hoist maybe is a normal maybe T. Okay. Okay. True name is maybe T of, oops, that. Name full mapping. Okay. Okay. And if the true name is there, then that's the path I am giving back. Okay. Okay, that's a lot of changes. Let's see if they work. What did I change here? Oh, yes, of course. Here. Oh, also, of course, in core, name is now the last argument, the last thing. So here. Oh, God. I really need to save those layouts so I don't have to do them manually. Good enough. Wait, why do I have... Yeah, this is correct. I wanted to check one thing, which was... Here in core, yes, that's here. Function name is the last of the things here. Okay. So, what's wrong? Partially resolved type gives additional things. Here it gives the name, but the name is not required. And because here I'm just putting the true path, and that's what matters. Likewise here. Okay. This go is missing the maybe name here in its type, which is present here. in the call to partially resolve here or into nothing. Okay. Defied but not use info. Okay. And with that, we should be getting close. Hoist maybe is not in scope. That means... Wait, it's not in scope, really? Oh yeah, I no longer have maybe T in the core. Now we have some kind of error handling thing. Lead resolve path of 2 L's. Come on. Come on. There we go. Okay. So let's try this again. I'm seeing a thing I immediately like, which is that there is a version of A1 in the symbols. It is the wrong one, but it's still progress. And I think I know why. I think the problem is I try to instantiate a generic function. No, I use the full name. Is the full name? Is it? Oh, it may be just my rendering is wrong. Yeah, my rendering is wrong. Okay, that's reassuring in a sense. Render name. Render name will take a name. And how do we render a name? I suppose it will be a pack of something. And I guess this will be okay. This will be a list of things with underscores. Okay. Is there a risk of that being ambiguous? With like, if I just flatten the list of type arguments, is there a risk of it being ambiguous? I think the answer is no, because the number of types will always be, yeah, it should be fine. There is no problem with associativity with like fixed number of types, so it should be fine. So I should be able to render a name. Well, that being said, it doesn't matter. Rendering is purely for debug purposes. I will be using the proper comparison within the code anyway. So this is gonna be a although I guess I could just actually render them completely differently. Yeah, no, I could do something a bit smarter than that. I can do that. And then I guess I can do a case of the name parameters of empty list to just that. And if there are parameters, then this will be base name followed by open bracket followed by intercalate with a comma something followed by a closing bracket. There we go. And this will be the names of the things within. So this will be a map, so text, I suppose, a map render name of the parameters. Okay. And so here I can, for all of those, instead do a render name name render name. It's just name, I suppose. Yeah, it's just name. 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 Okay. Okay, this compiled. Let's see what we have now. We do have a1 of int in the symbols. So that's good. We have instantiated the function. We have instantiated a1 of int, and we have included it in the symbols. And if I look at a2, which is also part of the exported symbols of the a module, the call expression points to a top-level declaration whose full name is a1 of int. So we have the proper name for the call, so that we will be able to link things properly because we have the proper function name there, the fully qualified function name with the type argument, and we have included the instantiated generic function in the symbols of the module. And we also export a1 as a generic function so that other modules may be able to instantiate it. Now, let's try to have a look at this. Hey, A shouldn't have changed, but after that in B, what symbols do we have in B? We have a1 of character. We have successfully instantiated a function coming from another module that is included. We have the a1 of int. It's there as well. Oh, but I don't have. But B doesn't have its own function in this. Oh, is it because they're generic? Oh, B1 and B2 are labeled as generic functions. Did I do that? Was it an accident? Oh yeah, they are generic functions. That's correct. But I don't want them to be, so let's remove them. And now there are no generic functions in B, and the symbols of B contain the a1 of character, a1 of int, b1, and b2. It's working. We are instantiating generic functions. Okay, now let's try something. I just want to import a1 here, and in A, I want a1 to make use I want a1 to make use of some function foo that does nothing, that's fine, but I want to call it here. Because what I want to check is I want to check that this, when we do the instantiation of the function, we are doing it with the correct scope, and therefore that foo calls this one correctly nonetheless. It does not. Okay. What's happening here? What's the error that we got? Error import path. That's the wrong syntax for B. This is the syntax for importing things, I believe. Yeah, there we go. So this compiles now, which means we are doing the instantiation of the functions of A in the correct scope for them. And in theory, we should be pointing, the function call points to A foo. Perfect. We are pointing to the correct top level declaration for the function call. The E in the symbols of B. I'm glad this is working. There was a lot of work to get there. Now, what do I want to check? I think something a bit more complicated I want to check would be, let's comment this all out. Let's keep A1. It's perfectly fine. I'm just going to remove the call to foo. Okay, so this ID function called A1. Now, actually, I'm going to change it. So it makes, let's try errors. Let's try type errors. Let's try x plus 1. This will only work when that's an int, which means that here, B2 should not compile because it's trying to instantiate A1 with a character which is not valid. Okay? So A compiles. We do get the generic function A1, no symbols exported, and the definitions of A1. However, in B, I do get an error wrong type. And I don't have, since my error handling is absolutely piss poor at the moment, I don't have a way to know where the error was thrown. But error wrong type is clearly expecting an int got a character. Clearly that's something that happened during the instantiation of A2. Okay. I'm very tempted to just improve the diagnostic level thing because I do have that information now. Like just dump the current context in in the diagnostic. That's why I make command line debugging horrible, however. Because I would like to check that this is happening not because A1 is expecting an int, but because we are instantiating A1. Okay, let's do a tiny bit more work. So let's change the thing. So diagnostic, yeah, will be something along those lines, yeah. Module name, declaration may be identifier. Or maybe I'll do something a bit smarter than this. This is maybe name. And I can check whether it matches the module name to try to be smart. I mean, like in the evaluation of the function or while instantiating other function, something like that. location is good, and then we can have the message. That's the message. And that becomes case diagnostic message. Although I guess it could be put on the that's fine. That's fine. So all of those take diagnostics, that's fine. Well, no, actually they don't. No, they take a message. This one is really bad. Is that because I need it for... Is that because I need it for the top level of the analysis? I think it might be because I still don't have a top level monad here, so I'm just doing a run maybe T here. Yeah, so those errors here need to happen. Oh, this is a weird indentation. There we go. Need to happen in some kind of monad, and it happens to be in... Yes. Okay, that's what it is. So that means that this no longer works. So that means I need to make some nonsense from the message here for now. Although I guess the module name isn't required. It could be... Yeah, the module name can be added afterwards. Okay, so that's fine. So that's diagnostic that contains no name, initial location, initial location, and the message. Okay, that's ugly, but that works. However, where we can do something interesting is in this context here. Report here in this monad will be able to yeah, I probably want this, and this is error message, which operates on the message. And is error, which operates on the diagnostic, which is error message of the diagnostic message. Is it called info? It's called info message. Okay. So now I can use this back here if it's an error message. And then here now I can extract I can't use the current things because current context will crash if we are at the top level. That being said, I do run an analysis and then I immediately... I'm tempted to do that for now. Okay, so current... Okay, so name is use current name. Location is use current location. And I am creating a diagnostic, which is just the name, the location, and the message. Okay, I just need to make sure that this thing has a show instance. Okay, let's try to compile that. What are you unhappy about? Initial location. Ah, it needs a file name. I don't care. For this, I don't care at all. This is completely temporary code. This instance will disappear one day. So I am okay with this. Oh, it's late. So now, let's see. I get an error compiling B. And I get this error while inspecting the A1 function. Oh, I should probably set the name. When I do the instantiate generic function, here I should do it with the full name. Oh. When I do the this context, that's where I need to do the full name. I was making a very recursive definition here. Okay. Now, this error happens when doing the analysis of the function a1 of a with the parameter car, despite the fact that we were in B, because we are instantiating A1 with that type parameter. And we get an error at line 35, sorry, line 2 colon 14. To colon 14. So basically somewhere around here. And the diagnostic message is wrong type because we were expecting. So that seems to be working. So we're this thing, despite being generic, works, trying to instantiate it with the wrong type in another module yields an error if we're doing the wrong thing. Now, I want to try something a bit more complicated. I want to try extracting the field t from x. This should compile because we don't know what t is, and therefore no type checking will be done as far as the module A is concerned. However, in B, if I comment that out, what I want to be able to do is I want to have some function b3 that takes x, which is going to be a foo, and returns an int, and it will return a1 of x. I need to define foo, which is a struct such that the field t is an int. What I want to test here is I am instantiating a function from another module with a type defined in this one. So it needs to have access to the local scope here to be able to like make sense of the names. For instance, if I uncomment this, put it here, call foo here, when I'm doing the instantiation of A1, it needs to know that foo means this one. However, when it checks t here, it means it needs to know if I instantiate this with the struct foo, it needs to be able to find the declaration of foo to be able to check this, basically. Oh, actually, that will not be correct then. Let's say int then. Oh, that works. Ooh, that works. Okay, so in the B module, I have a symbol for A1 with parameterized by B foo. And it's the oh, of course, that's the call to foo, yes, of course. And then there's a return statement with a of type int with a field access expression where the type is indeed a foo from module B and the field name is t. Oh, I'm happy this one worked. And if we do instead u here, while compiling B, not while compiling A, we get an error in A1 parameterized by B foo at line 6 colon 10, where the field is not found. No such field u in a B foo. Oh, that works. Ah, it's working. I want to check as well recursive instantiation. So if foo is parameterized by a parameter t, and I'm calling foo of t here, then we should see a foo of a foo instance in B, because by instantiating A1, we will recursively force an instantiation of foo. And I also want to test within the same module. So if I have I can do this with a basic recursive function, come to think of it. So I have B, maybe B4. So I have B1, which calls B2 of X. B2 of X, B2 is a generic function that calls B3. And B3 is recursive. And we'll never finish, but that's fine. What I'm hoping to see here is basically the fact I'm going to comment out B1. What I'm hoping to see is that when I uncomment B1, it forces the instantiation of B2, which forces the instantiation of B3. Parser error. Parser error in A. Line 5? Oh, yes. Okay, what's wrong? Ooh, internal compiler error. Ooh. That's the first one, I believe. Aha. So that means I have tried in B to instantiate a function whose definition was not fascinating. Oh, that's because I see. I see. I see what happened. Okay. Oh, this is gonna be tricky to fix. Okay. So what happened is here I have fully qualified the arguments to foo, which means that the instantiation of foo was scheduled not at the call site when we try to identify the type from the arguments, but it was at this site. Because here we do have the mapping, we have the names, therefore, oh, this is a generic function, we know the types. Wait, no, that makes no sense. Wait, no, that makes no sense. Wait, no. When we instantiate A1 from B here, so we instantiate A1 here, so now the type is known. So when we resolve this function call, then the type is known. So we are indeed doing the instantiate generic function here. But for some reason, we try to instantiate another function. We try to instantiate it, and for some reason, rather than finding it in the foreign functions, we don't, and therefore we register it as part of this module, which is wrong. Interesting. And since we're registering with its full name, when we're trying to look for a definition of a foo before we have actually instantiated it, wait, that means that we've done a module instances with. That means that here, this one, the name we have given here was the fully qualified name. That doesn't make sense. Okay, good old debug trace to the rescue. I hope all of those things have show instances. But clearly, we are calling that function that tries to instantiate with the full name, which is and therefore it doesn't find it in the foreign ones because it's calling it the true name. Yeah, I see what's happening. Weird. Debug is only shown once here and never after. That's weird. Yeah, params t name parameters. Okay. Yeah. So this is the one where we find a call to a foo, and we have a mapping of t to a top level declaration. Okay. So in this case, we will try to instantiate the generic function. All is concrete mapping, that is true. And here that means that the foreign functions did not contain the name a foo. And since it did not contain it, that's weird. So why doesn't the foreign function contain foo at all? It should be there. A foo should be there. Okay. Okay. Okay, let's try that. Here, I'm gonna remove those that are useless. I'm gonna copy this here. I forgot to compile. Okay, so I am calling with t full path a1. Okay. Aha, so I do have a place where I'm trying to call with the name parameters. So yeah, I am calling with the wrong thing. But the weird thing is, oh, I know. I know. I know. Okay. Because there's a foo here which is fine, and there's the a foo here which is wrong. And that's because. Ooh, tricky. Okay. I should really take a break at this point. But I want to finish this. What happens is this. We call foo fully qualified. So when we instantiate a1, the call to foo, being fully qualified with the arguments within the brackets, is known. So in partially resolved function type here, we call try instantiate generic function, and it succeeds. We instantiate foo. And as a result, we get the true name. However, this is in the context of a function call. So when we return to here, in the call expression, we have the resolved path, the fun type, the mapping, and the function name. And what that means is that here we try again to instantiate the generic function with the name that was returned, which happens to be the true name. Which means, I think, the simplest solution to this, the simplest solution is to just, although I don't like it that much, check that there's not a true name. Check that it's not the name. I'm not trying to instantiate a function that is already instantiated, basically. So, to be valid, the name parameters of the name should be null as well. Otherwise, it means I have given the true name of a function, which means it has already been instantiated. Okay, still broken. But this is not an internet compiler error. This is an actual error. We have, while trying to compile B, while trying to compile B2 at line 18, error function ambiguous type for B3. So in B2, the type of B3 is ambiguous. Oh, yeah. Wait, no. It shouldn't be, right? Because I am giving it an argument of type X, which is a T, so it should be able to figure out huh. Interestingly, B3 has the same problem where it considers itself this call ambiguous despite the argument being given. Okay, and this is when trying to analyze B2 without name parameters, so not the instantiated version, and B3 without name parameters, so not the instantiated version. So this call to B3 is ambiguous despite the fact that X is here. So that's not a bug in something we've done this evening. Oh, actually, B1 should be uncommented. No, actually, it should be. That's fine. So it's not a bug in something we've done this evening. That's a bug in something else. That is a bug in the analyze function called args thing. Mm-hmm. What about the placeholders in this? Why am I not accepting placeholders when analyzing? Why am I not accepting placeholders? Oh, wait. This is the field type, which is the function archetype. Okay, so we are in this situation where the field type, the argument type is a type parameter, the one of B3, for instance. And we found something that is not the same because it is, okay, and they do match. So we report that the T of B2 matches the T of B3. And here I have an error function ambiguous type. Why do I have the same? That looks very weird. Okay. I suspect it's a problem of placeholder and type parameter nonsense. Okay. So trace show m trace m actually. Do I have the name of the function? I have the path. So show resolved path plus, and let's show them all diffs. That will already immediately tell me if something is wrong. Well, at that point. I wanted to stream tomorrow evening. At that rate, I don't know if I will be awake then. Okay, so okay, so I found no diff, which is incorrect. Okay, I need to check the difference between those two things. So on the left-hand side, I will have a type of the argument to the function. On the right-hand side, I will have the argument I'm providing. Those should result in, hey, we found something that gives a potential match to a type parameter. We haven't, so something is broken. But this is what we should find. Okay. Aha. Wait. Oh god. Okay. Okay. So for some reason here, when we're trying to resolve the call here and decide, okay, what is this argument? Can we figure out what its type is? It has somehow already been resolved as despite being the argument of B3, it has already been resolved as being the T of B2. And therefore, the T of B2 and the T of B2 are the same type. There's no diff. Okay. Why? How is that? How could the field type... can the function archetype be wrong like this? I suppose it means that the call args thing has done some type resolving already at this point. Like here. God damn it. Wait, no. I still think I know what's happening. I think the problem has been introduced by where is it? This. Because I am resolving a path, which is I'm partially resolving the function type, which means I have to traverse force fun arg on the fun arguments. Where's that define again? There it is, force fun type, force type. Which is a resolve type, basically. Okay, so I resolve the type of the arguments. When I try to resolve the type of the arguments, I resolve the path. And in the current scope, this is a type parameter. And I'm confusing the type parameters with wait, but this is still role params the same. Wait, unless it has already been resolved. That's it. That's it. That's it. That's it. If the function has already been resolved, then I don't do a force resolve type and I interpret the template parameters within the context of its own function. But here I'm doing a partially resolved type on a function that has not been resolved yet. So I'm trying to look at the types and like, okay, I need to know what the types are. I need to know what the types are, and I'm interpreting the type parameter in the context of my function. Okay. This is the only place where this can happen. Okay. So basically, when I do this, I cannot do it in the current context because my current context is wrong. Okay. That means here, in the case where this force actually does a type evaluation, it's doing it in the wrong context. So I need to do this with context. Just in case they are not resolved yet. So I will need the top level scope. I will need the name of the function. I will need its location. Do I have that? I don't. Can I get it? Yes, I can get the location. Yes, in all of those, I can get it. Okay. So I'll need the location. Location here. If I have to do this partial resolving of types, then it has to be done within the context of the function. So name and block, I guess. Okay, so we create a pair of those two things. And on nothing, something fail, we abort. Now, this means we will be interpreting the types and everything as if we had started the analysis of the function. So we will treat no, not that. There we go. Okay. Okay. Now, this is not correct yet. Because I want to check that I am forbidding placeholders correctly here. Yes, I am. Forbid placeholder. Perfect. Okay. So now this would be correct. I'm going to have one issue, which is that set type parameters will need to be in the boot file. Annoyingly, which means I'm going to also need tokens here. Okay. Okay. Let's see. This is missing an argument. Because now partially resolve function call function type takes the location after the name. I guess I could not decompose this here. It's fine. So here, this is the location of the definition. Here, I need the location after name. That's this. Here, partially resolve function type. Name, I am missing the location, which is location def. I am starting to be tired, but hopefully this is the last big change. So, with context, yes, this is not on nothing, this is an on nothing M. Is that it? Hopefully. Okay. Basically what this does is this function simulates trying to do the analysis of a function, but only does the bare minimum required to be able to check a function call, which means basically checking the type of the arguments and the return type. However, since I was not doing the same mechanism that I do for a proper analysis of functions, if the function had not been analyzed yet, those type analysis were done with the wrong context. We still got an ambiguous type. What? Ah, I see. Okay. I see. Okay. Now, having done this has fixed this case where B2 calls B3, and this is no longer ambiguous because the type of X of the argument here is assumed to be the type parameter T of B3, and so we can do the usual matching inference. However, what's happening here is that the argument of B3 of X is assumed to be the template type parameter T. And so we know that the type of the argument is T, and the type of the given is T and the expected is T, and it's the same T. Therefore, my code that does a type diff to try to figure out, where we have a type parameter on one side, what do we get on the other, is wrong. Because it finds that there's no difference. it is the same type on both sides, therefore does not attempt to do a matching there. I think my type diff function needs to be reworked. Okay. I think I'm gonna do something ugly as sin. I always use type diff to make a comparison between a call site and the values to it, or for a struct, field struct, and the value given to it. I think in the case of type parameters, I always want them to be reported as being different. Or rather, when there's a type parameter on the left hand side, I always want the difference, I think. This will need so many tests. But now, this compiles. So now, oh, we do have symbols. Why do I have symbols for... Oh, generic functions. No, okay, we did. So the B module contains some stuff from foo, contains B4, that makes sense, contains A1, makes sense, and B2 and B3 are generic functions. And the recursive call in B3 is a call expression that calls to B3 with the... Why is X not recognize? It's a path expression, I suppose. Yes, that's true. That seems weird. This should be recognized as being... Call X. Something is weird there. Oh, wait, no, of course. Of course. This is because this is the parsed version, not the resolved version. If I look at the resolved version, B3 will have a call expression that calls B3 with an argument which is a type parameter named t, and its value is a function argument x. Yeah, okay. There's probably ways to clean. No, I think this is correct. Okay. Okay. And so now, if I uncommon b1, this will generate a call to b2 instantiated with an int. Meaning that now there will be symbols for b2 of int and b3 of int in the b file. b2, b3 are still generic functions of the b module, but the symbols contain b1, b4, b2, and b3. There we go. It works. It all works. So now it's done. We have instantiation of generic functions. We have a symbol table for every module that we build. We don't have a proper compiler yet that does like a dependency graph of the different modules or anything, but that's an easy part to do at the end. Now we are able to instantiate generic functions properly and create symbol tables. And we have better error messages, slightly, very much slightly. Okay. I've been doing this for 8 hours. Time to stop. That is so much progress, and also a lot of the changes I've made this evening will need to be documented. A lot of this is very ugly. As I was mentioning earlier, I don't know how I want to approach documentation for this project. I don't want to write code outside of the stream, but a stream of documentation is not gonna be super interesting, I think. So I'll have to think about it. Maybe some low effort stream outside of the regular hours just for documentation, perhaps. Because now a lot of this will need to be documented. Because as much as some of the structure of the big functions and how this is structured makes some sense, some functions like typediff are now complete black box, excuse me, that are extremely unintuitive. But at this point, except for a few things like vectors and strings, we have finished the analysis phase. Come on. There we go. If I do another stream this evening, I'll probably start doing a bunch of tests, basically just clean up tests and documentation before I go on vacation. Try to leave this in a slightly better state. I'm so glad this is working. It was really stressful to start thinking about. Like, it was really stressful to try to figure out, like, a lot of the decisions I've made in terms of like name, types, roles, all that stuff. I was not entirely convinced all of it would actually work. And I was stuck for like a few weeks at the beginning of the analysis by like, how do I represent those things? And now it's working. Could be cleaner, it's working. And that's a relief. So, tomorrow evening, cleanup stream, test stream, low effort stream, and when I'm back from vacation, we start doing the lowering to IR, which is gonna be its own can of worms, and it's gonna take it's gonna take some time to do, but that is the next step. I am now going to go crash pretty hard, and thank you everyone for tuning in. That was fun. That was a lot of progress. That was instantiation of generic functions, and yeah, I'll commit this and I'll go to sleep. I am too tired to try to make this a proper incremental commit thing. Good enough for 4 a.m. Okay, well, thank you again, everyone, and I'll see you probably in 16 hours, unless I'm too tired this evening to actually do a low effort stream. See ya.